All right. So, Hugh McKee is a developer advocate at Lightbend, and today he will be talking about event-driven services as neural synaptic services. Please go ahead.
Thank you. Good morning, everyone. I'm a speaker. I speak at conferences a lot, and I've been talking about event-driven systems for some years now because I really think they're very, very interesting. And I've been building systems using it as a developer advocate. So I've got like decades of experience as a backend, like Java developer, backend systems. So now I get to build systems for fun and demos and things like that. But I've been fascinated with event-driven. And over the last year, I've been using something else, and the hint is it's called this, Calyx. But that's kind of changed my perspective on how to do software, and especially how to do event-driven software. So I think event-driven software is very, very interesting. But this approach that I'm going to kind of show you as well, I think is interesting also. So maybe you'll think I'm crazy. Some of my colleagues think I'm crazy because I'm talking about this like neural processing with event-driven. But we'll see. You'll be the judge. So what I'm going to do is I'll do a review of event-driven because I think a lot of people have heard about it. If you're a back-end developer or even full-stack developer, but many people haven't used it. And then I'm going to show you a bit of code. Don't have a lot of time, but I want to show you a little bit of code and a different style of code as well. And then I'm going to go crazy on you and get into this concept of this, what I call micromind. I've been playing with a name, neurosynaptic services and micromind, those types of things. But it's an interesting processing pattern. So with event-driven, one of the things I've been working on is a demo that's been a lot of fun for me, and it's called Earthship. And the reason it's called Earthship is that the user interface that I built is a map. It's like a Google map, so you can go anywhere on the Earth, and you can zoom in onto a location on the map, and then you can pick a circular region, like you can see the circular regions here, and then you can say, I want to create a simulated number of orders. So this is like an e-commerce system. This is like, the shopping cart demo is kind of like the hello world for back-end applications. So I started with this simple shopping cart app, but that got boring really, really fast. So I wanted to make this more interesting. And I wanted to do more interesting things with the demo app. But I always like to do this visual stuff so that you can, and this is on GitHub. I got QR codes where you can go grab the repo. But the idea is you zoom into a location on the map, anywhere on the map you want. You could be in the middle of the ocean, or it could be over a city, or wherever you want to do it. And then you can specify how many orders do you want to create. You want to create some like a couple hundred orders. You want to create 1,000 orders. But what I wanted to do is kind of have this demo put a hurt on the back-end system, really put a load on this system. And another thing you can set is a rate, like orders per second type of a rate. Then one click goes into this demo app, and it starts generating a bunch of orders. So all these dots represent orders that were randomly distributed within this circular region. So this is a design diagram of this application. I'm not going to be able to go into a lot of detail with it, but it is event-driven. So these rectangular boxes represent basically event-driven microservices, but they're of a very specific type. They're probably not like maybe what you've seen with other event-driven before, because they're very focused on what they do. But what I wanted to do was show kind of visually what happens. So you can see in the bottom left, there's a client. I'm kind of highlighting a client, and it's sending in a command to a shopping cart service, and it's adding items to a shopping cart. So it's loading up a shopping cart. But the interesting thing is when the command comes in from the client to say checkout. So the service is emitting an event, checkout. Now, this is where things get interesting. That event is of interest downstream to another service, which is to create an order. So that triggers the creation of an order. So this is an event-driven flow. There's kind of a cascading sequence of events. But like I say, this got boring really, really fast. So I wanted to plug in this UI. So the map in the top center there is sending in a single HTTP request to say, like create 500 orders at this geographic location within this circular region. So that goes into another service, which starts triggering the creation of these orders. But you can see there's a flow, like this generator got the initial request. It starts emitting events over and over to create these, what I call geo-orders. And these geo-orders are just orders at a specific geographic location. But here you can see the event coming out of geo-order is of interest to a couple other services. And the point I want to make here is that each of these services, one of the things we've been talking about with microservices forever is they're supposed to be loosely coupled. And these are loosely coupled services. These services have an API, but they don't know who gave it, send them commands. These services also emit events, but they don't know who or what consumes those events. They don't care. So every single service is only concerned with its own functioning. It's not concerned with the rest of the system. So this geo-order service emits an event, which happens to be of interest because of the wiring of the system to a couple of other services. But now we go deeper into the processing flow here, and I'm not going to go through what's happening here, but other than what this system does is allocate stock to the orders. So it's doing something a little bit more interesting than just taking orders in. But you can see there's this kind of cascading flow of events that are coming in. Get rid of this thing here on what it is. That, where the processing is occurring. So all these highlights are these cascading flows for where commands come into one service, it emits an event, that event gets picked up by another one. So the logic of this system is built in, it's kind of decomposed down into these individual, very focused little services that are wired together to orchestrate the whole processing of the system, where it takes orders in, allocates stock to them, and reports back to what the processing is. So this is the general flow of this system. This is a really different way to design a system. Like I said, I've built backend systems for decades, and with regular databases and CRUD-like operations, multi-table transactions and all those types of things. This is not that type of behavior. So the design of this application was really interesting, where I decomposed the problem down into each of these services as solving a different part of the problem. And it has this processing flow, and including things like allocating stock to the order. So that's kind of what this demo does. It's a fun demo to run visually on the map. When the orders are first shown, they're grayed out, indicating, okay, the order's there, but we haven't processed it yet. And then just over a period of a few seconds when it runs, the orders will turn blue when they're allocated stock, or they'll turn red when there's insufficient stock, so the orders go into a backorder state. But that triggers other behavior that's in this design, which will order more stock, and as that stock comes into the system, that stock goes looking for back orders and fulfills those back orders so that all the orders get processed. Now, the other interesting thing is that there's three fundamental components that are used to build this system in this platform. There's the rectangular services. They're called entities. And like I say, they have an API. It's a simple API. I'll show you the code in just a minute. They have logic. Basically, there's the service composes the state of a thing. It's like this shipping order item, for example, that's in the middle of this diagram. It's just a durable object, basically, that this thing is processing. And then it's emitting events. Now, as event-driven, the events are for changing the state. Like with a shopping cart, you add an item to the cart. Well, that's a command coming in. If the cart's not checked out, you run the business logic. If the cart's not checked out and it's a real product and everything looks good, then the item gets added to the cart, which means you're altering the state of the shopping cart by emitting an event. So the processing is a command comes in, it creates an event, the event gets persisted, and once it's safely persisted, then the event is used to alter the state of the object, and that's the processing flow. So the big difference here is that these services are really simple. They don't reach out. They don't talk to databases. directly. The state is recovered from the event journal. So like, what is the current state of a shopping cart? Well, it's got, add item 3 times, change an item quantity, remove an item quantity, checkout. The aggregate of all those events is the current state of the shopping cart. This is the basic behavior of these services. So let me show you a little bit of code. Here's the shopping cart service. It's in Java. Anybody Java Spring developers here? Some? Yeah. So some of this should look familiar. The API is definitely using Spring-like annotations. But you can see that on this line here, number 26, I have a class, and it extends a base class. It's called an event source entity. This is part of the software development kit here, this Calyx software development kit. But then here you can see, here's how you define part of the API, like add an item to the cart. But the main thing I want to show you here, because there's a lot happening right on this line 49, you can see there's above it's like effects.emit event. So what that is, that's the code that emits a new event that needs to be persisted by the underlying system. So this is a high abstraction. I just gave a talk earlier this week at another conference about high abstraction platforms, and Calyx is one of them, but I talked about 4 different ones. These are higher abstraction platforms that are abstracting away as much detail as possible. So this code does not connect to a database directly. It's connected to a database indirectly through the platform layer that's below it. So the goal is to simplify development. So here it's like emit an event. I don't know where it goes. I don't know what the database is. I don't care. That's the problem of the platform. My problem is worrying about the business logic in this service. So it emits an event. The next interesting thing is this current state. The current state is an inherited method from the base class, which composes, has the state of this thing, like in this case, a shopping cart, as it is right now, retrieved from the database. This is also a stateful service, meaning that the state will be cached, kind of in a very kind of elegant caching mechanism where if the shopping cart's active and there's a user adding things to the cart, that cart's in memory somewhere in a cluster. There's one instance of it in memory somewhere in a cluster. And it's just, instead of having to retrieve the state every single time you're going to make a change, it's just, it has it in there. But all that's being managed by the platform as well. You access in our code the state from this current state. And then this event for is a method I wrote. It's just my style, but it's really simple. It's just taking the command in and creating the event back and returning that. So these APIs, you can see the API, like add an item, change an item, remove an item, check out. This is all I'm doing. And then the next thing here is these event handlers. So the event handlers are invoked once the event has been safely persisted to the database, and and we want to now make the state change. So if you look at this method, you can see that it's returning the state. Okay, so that's the state of the shopping cart, altered by the event. So like with the add item, I'll go into this on method. You can see this is just basic Java. The object here has a list of items in the shopping cart. So all I'm doing is streaming through the list and adding the new item to the shopping cart. Very simple, no database, and nothing like that. So there's all these event handlers for the different events. And then the state itself is just a Java record. And I really love Java records. It's one of the best inventions come out in Java because they're immutable. So that means that I can't write code where I'm going to screw up and change the state when I shouldn't have or something like that. So it's really quite nice. But I have these event, just kind of overloaded event for methods for all my different commands. And then I have the on methods, overloaded on methods for all the different events. And that's the basic flow of this class. So no database connections, no worrying about publishing messages, things like that, but you can see that there's messaging happening in this system because the event from a shopping cart, like a checkout, is being picked up and processed by downstream services. So the other component that I wanted to show you is the shopping cart to order. And here I just want to show you really quickly so I can move on. This is called an action. And actions process the messages from upstream events. So the event comes into the action, and the action translates, say, a checkout into a create order command. And it sends that create order command to the downstream service, the order service, to create an order from the shopping cart. So the logic in here is really simple. I'm not involved in polling or anything like that, or talking to Kafka or whatever high abstraction type of code to do that. So that's kind of the code. So I want to get into the micromind piece here. I'm going to go a little crazy on you. And when I was working on this design diagram, and my goal for that design diagram, where I was showing kind of the cascading sequences of events, was to help people visualize, a flow and kind of a real event-driven type of a system. And I thought it worked out pretty well, but it took a lot of work. If you guys ever heard of Blender, Blender.org is a fantastic 3D tool, and I love Blender. And I'm going to show you something else that I've done in Blender in just a minute that I love. But so this diagram I did in Blender, but it was a lot of work to do all this animation of highlighting each step of the processing flow. But it's like when I was looking at it, it's like, okay, wait a minute. The way these services are working and the way there's this kind of cascading sequence of events that's occurring between the services, I started to think, wait, this is somewhat like the behavior of the neurons in biological brains. Neurons in biological brains have a state, they have like a charge. They get signals in from other neurons or other sensors like touch or pain or whatever. But the neuron itself doesn't know who sent it a signal. All it knows is it received a signal. The neuron decides, should it emit a signal? So it decides it emits a signal. It doesn't know or care who is wired up to receive that signal. All the neuron knows is its basic mechanics. And that's kind of what these services are doing here. Really simple, really focused, not complicated, not doing database transactions. It's kind of a pure, kind of an event-driven type of thing where signals come in and signals go out, and there's some logic in the middle to decide when, how to respond to incoming signals and how to emit outgoing signals. So that kind of blew my mind because, like I said, shipping order, it gets a command in, does a state chain, emits an event. That event gets picked up by an action because it's subscribed to it. That action takes that event and translates it into a command and sends it down to another service. There's your flow. So it kind of blew me away. So again, just kind of walking through it really quick, you can see this cascading sequence of events. Step by step, this is the exact flow of the way this application works. And what it's doing, it's not just taking in orders, like I said, it's allocating stock. And what this system is doing, with just these 13 simple services, it remembers exactly where every physical unit of stock went, to every single order. All that is being handled. It's also handling back orders, like when there's insufficient stock in the system, and when stock comes into the system, it has logic to add stock to the back-ordered orders, find them and allocate stock to them. All this behavior is in a relatively simple service. So that's what's kind of cool here. Again, my colleagues think I'm nuts talking about this whole neural thing, whatever, but I don't know. I'm pretty psyched about it. The other thing that I thought was really interesting was that there were behaviors that were starting to emerge, recurring behaviors that I hadn't seen before in other code. So, for example, there's like 5 or 6 recurring behaviors. I'll give you a summary at the end. But of the 13 services here, 3 of them kind of use the same kind of a hierarchical tree pattern. I call it a reduction tree. And once I figured out how to use a reduction tree in this kind of a processing, and this isn't unique to Calyx, this I think is unique to this style of doing event-driven, that these patterns started to emerge. So there's all these different reusable patterns that are starting to emerge here. And that intrigued me even more, that maybe there's something really interesting happening here. Because I'm starting to think that the way our brains, biological neural networks are put together, it's the same type of thing. There's these recurring patterns in the way all the things are wired together that are being used to do very, very powerful things. So it's this whole idea of services behaving more like neurons and other functions and behaving like synapses. By the way, this is all serverless as well on this platform. So these things are running in a cluster. They're getting allocated when needed. It scales up, it scales down, those types of things. So what I want to show you is another visualization of processing the services. So what I did was, before I play it, because I got time, I wrote specific log statements in the application so that I could scrape those specific log statements out of the log and use that as raw data to render the activity within the Earthship demo as it was processing orders. So what happens here is that that's one shopping cart getting processed and stock getting allocated in the system. And then the two other shopping carts come in. But the fun part starts here, like, there it goes. Now 200 orders are coming in from the map. And what's happening here, every dot represents an instance of one of the services getting created. And the colors represent state changes that are occurring. So red indicates back orders. And yellow indicates things that haven't been processed yet. So it's processing. And green indicates that, yeah, the stock's been allocated to the order, and it's flowing back up. So you can see it's fighting, it's actually recognizing that the system's out of stock. That triggers stock getting ordered, coming into the system, and getting processed. And you can see things turn from yellow to red to green, and everything gets processed. And the lines that we're flashing represents the specific messages. Like event came from a specific entity to another specific entity. So these lines aren't arbitrary. This is real data from the running of the application. And it's 3D. So this is the beauty of Blender. I wrote this code, by the way. It's Python. Blender has a massive Python API. I've been wanting to do this for years. I've been using Blender for a long time. But I used ChatGPT to help me write the Python code to do this. So this was a blast. I was so happy when this video worked, because what I think is really interesting here is, I don't know if you watch videos on, say, the processing of neural networks, or the processing, some videos are on YouTube, say like of insect brains, or human brain activity, and all those types of things, really awesome looking videos. And I wanted to have a video like this, but for a software system. So this is about 10,000 entities were created, about 15,000 events happened, as processing all these 200 orders. And then I already know some optimizations that I can do to this to cut things down some more. But the other thing is that this system is, it's built to run in a fully distributed environment. Scale up, scale down. Any part of this application can break, and when it comes back up, the system picks up where it left off. It will keep running until it's finished its processing. Unlike AI systems like large language models, which, have you heard about it'll lie to you with confidence, or that they hallucinate, like ChatGPT and everything? Yeah, I've seen it do it. You ask it a question, it says, "Oh yeah, here's the answer." You look at it and go, "No, that's not the answer. You're smoking something." This system is not, trained. It's hardwired. It's got instinctive behavior, not trained behavior. So it's enterprise precise. Like we're using these patterns to do things like financial processing. And with financial processing, it's like you don't go back to your management and to your business sponsors and say, Oh, it works most of the time. Every once in a while, we'll screw something up a little bit. No, that doesn't fly, right? So this is absolutely precise type of processing. And for example, decrementing stock. This knows exactly what's happening with stock. It won't make a mistake with stock. It won't make a mistake, say, aggregating financial transactions into merchant payments. That's another system that we worked on recently. Those types of things. So it's fully distributed, fully scalable, fully resilient, and absolutely accurate. And the nice thing is that I write this code, and I'm really kind of focused on the pattern of the code, not worried about resiliency, not worried about scale, not those types of things. Of course, when you're doing IOs, you're always thinking about, in my code, can I reduce the number of IOs that my code is doing? Those types of things. But it's a whole different way of thinking about building applications. So to kind of wrap up, what I like about this approach is that the microservices behave more like neurons. I've been talking about microservices pretty much since they came out. And some of the things we've been talking about, but not necessarily doing, is things like microservices should do one thing and do it well. In this case, you're kind of forced to do it that way. And the behavior of the microservices, commands come in, commands emit events, events get persisted, and then the events trigger state changes. That's the flow. Those actions, those synaptic type actions, they're just consuming events, from upstream event producers, and for the most part, they're translating those events into downstream commands. They can do other things, like they can do queries against views and things like that. Like, for example, when I'm allocating stock to the order, the action has to do a query to see if there's any available stock to be allocated, and it grabs that stock from the query. The messaging in the system, I don't know or care how it's implemented. I do know, but I don't care because I work for the company that built it, and I talk to the engineers that built the platform all the time. But that's not my concern as a developer. As a developer, I'm focused on wiring together the flows, defining the flows, designing the flows, and in my software at a very high level of abstraction. But the messaging is at least once. But that also means that you have to consider idempotency. And meaning that with at least once messaging, what that means is the consumer of the message will get a message at least once, and it might get that same message twice. So if you're doing things like decrementing the balance of an account or taking inventory out of a stock or something like that, you have to think about that. How are you going to handle the processing logic when those types of things happen? So I mentioned the patterns, and in the Earthship, relatively simple demo, there's two, it's called choreographed sagas. The choreographed saga is the saga pattern without a controller, so that the saga happens just because of the way things are wired together. There's a lot of these actions that do one-to-many, meaning that one event comes into the action, but it emits multiple commands to multiple downstream services. That's a very common pattern. There's generation loops and generation trees. This reduction tree I mentioned earlier, there's 3 of them in the demo. And the reduction tree is really for that. It's reducing something like, how many back orders do I have for a particular product? How many with the stock orders they're in, how much inventory do I have for a particular product? The reduction of all that detailed data is being handled by these reduction trees, and they're really there for idempotency. So, like I said, this is a different way of thinking about doing event-driven. Maybe you don't have a platform that does it, but so that's okay, because I think event-driven itself is right there. So we did a review, looked at some of the event-driven architecture, looked at a bit of the code, and went into this micromind. I want to leave you with 2 things. This quote from Alvin Toffler: the literate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. I had to unlearn a ton of stuff and relearn new ways of doing things to use this new tool set. It was hard. I think we've discovered some patterns that will help people that follow us later on. But this is a skill set that I think every one of us needs to have if we're in IT. And this one's relatively new. AI will not replace you. People using AI will. I use AI like all the time. Most of the images that are in my presentation are AI created. I've been using Copilot for a year. GitHub Copilot in my IDE for a year. It's amazing. It's like I'm sitting there, every once in a while I'm working at home and I come out to my wife and it's like this thing's in my head, it just reads my mind. It's just dumping out blocks of code and I'm just moving. It's amazing. So thank you very much. This is the QR code for the slide deck, and I think we have a few minutes for some Q&A if you guys have any questions. Yes, sir.
Yeah. So I saw some checks you did in that microservice, and they returned an error. So how those errors are propagated? What happens with that?
That's a really good question. The only reason that particular service, the shopping cart service, had that validation checks in it was because there was a client, an external client, talking to it. The other services, and I think what you're getting at is when you're cascading, wiring services together, a service just can't reject, right? So this is very insightful, excellent question. The service has to have like a compensating action. So instead of just saying, no, I can't process this message, it'll emit an event saying, no, I didn't process this message. And that event goes back, is wired to go back to, say, the event producer. That's a very common pattern that was in this type of a system. But so you have to be very careful about just rejecting incoming commands. And it's only really for services that are on the edge of the system, where there's external clients that aren't event-driven clients and can handle the error response. Any other questions?
So I will ask a question. So what about learning, right? Because you compare this to neurons with synapses, and the synapses grow and shrink based on feedback. Does this happen in any way in this system?
No, it doesn't. Not in this system. It's not yet, at least. So it's what you mean, like training it with, yeah. So that's an important distinction, that the service, the behavior that's in this system, I kind of refer to it as instinctual. Like when we're born and when other organisms are born with a neural network brain, there's a certain amount of pre-wired behavior in the system that doesn't need to be learned. And that's kind of analogous to what this system's doing. It's just pre-wired behavior. But what's interesting about this, I think, is that how powerful that pre-wired behavior can be. Like, don't put your hand into a fire because when you feel pain, you immediately react. A lot of that is instinctual behavior. It's not learned behavior. Some of it is, but it's, like insects, for example, they have some learning ability, but they have a ton of pre-wired behavior built into them. And that's kind of what this is. But it's extremely powerful. That's what's kind of surprising me. It's like, man, I'm doing all this stuff with just these 13 simple services. The code's not complicated. It's the wiring together that makes the behavior of the system really interesting. Yes, sir?
So, as I understand, there's no central piece of data that these services are accessing. So, is there a risk of creating loops like cancer, so to speak, where things start going on loop because each one is sending something there, there's no central piece of data that they're working for?
There's a state of each instance, right? Like there's a state of a shopping cart, state of an order, state of stock, state of product, those types of things. And you have to think about that as you're designing the system. That's the fun part. The part I really enjoy doing this is thinking through the design, thinking through the compensating actions. You kind of have a happy path where everything works just fine. That's kind of the easy path. But then there's the unhappy path. So things like there's services that like an order comes in and the order is decomposed down into its individual physical units of stock that it needs, and those physical units of order stock that need, they go looking for individual units of stock in inventory. And there's it'll send in a request to one that's supposed to be available, and that one's not available. So it emits an event that says, sorry, I can't join with you because I'm unavailable. Some other order got me. So that event goes back to the requester, which triggers it to just try and get something else. But maybe there's no more stock the next time it goes back. So you have to think through that. So what happens when there's no stock? So every single step you have to think through. It's not as bad as I feared it might be, especially when you're decomposing a problem into these small processing units. That's where I think it makes it simple. If you have a big, bulky service that's getting, it's got that smell because it's getting too big, then you know you're on the wrong track. And often the solution when I ran into that was to decompose it down into smaller, delegate, to smaller services. But you have to think about, make sure. I think we're out of time, so thank you very much for attending the talk. And I'll be around all day today, tomorrow. If you want to talk to me, I'd love to. Your only problem is shutting me up, so.
async. How does it work? You can hear me? Yes. Every silly thing I say, you hear now. There are chocolates, and there are Podman stickers here. That's maybe the most important.
Wait, what chocolates?
Belgian specialty. We want a chocotoff. Voilà. Another hand. Good. Another one. Right. Oh. That's too far away. Who was it? You were? So we don't have a Podman desktop swag yet, so that's why chocolate and Podman stickers, that's what I can offer. I have to wait 2 minutes, or can we start? Hello? All good. So, microphone working, everything okay, and people still coming in, so I will wait.
We have 2 more minutes. So.
Yeah. So I had to learn to use the Windows to work on the project. That's very fun. You introduce?
Yeah.
There is no more movement now.
So Fabrice works at Red Hat as a technical writer, and he will be talking about Podman.
Desktop. Podman desktop. A little bit about Podman, but mainly about Podman desktop. So that's the... So Podman desktop was announced as version 1.0 for just a few weeks ago. And we were all sweating the week before because it has to work. So it's a very young app, let's say that. We are building features like crazy in it. And when you build one feature, another one is broken very often. But it starts to be really usable to do nice things. So why Podman desktop? So how to explain that? It's that for production, you want to have your containers running on Kubernetes or OpenShift most often. And in development environments, people are more using Docker Compose, and other things that are just, okay, they are containers, but they are not working the same way. And and your container works on development, and then it doesn't work on production. That's sad. And that's a very nice picture explaining it by one colleague. So that's the idea, okay, Docker Compose and Kubernetes YAML, that's not the same. Let's try to give a tool to developers to produce the Kubernetes YAML and make it simple to produce. And that's why it's not just Podman, is that there is one part of Podman Desktop which is really using Podman, and the second part which is bringing you from container engine to Kubernetes and or OpenShift. You choose. I have a session this morning and one this afternoon. The main reason is that because we were 2 people applying for the sessions, and the other person cannot come. So I will focus this session more on what you can do with the container engine. And this afternoon, I will not talk about the container engine, but try to focus more on what kind of Kubernetes workload and features we have. So voilà. So one problem that we solve, and that I didn't talk about, is that containers work natively on Linux. You know, it's C groups, and so it's features that are really bound to the Linux kernel. And on Windows and Mac, you need to work in a Linux VM. And that makes it a little bit more complex. So it's more complex to start with Podman on macOS and Windows. And the first thing that Podman Desktop brings to Windows and macOS user is it's easy to start with Podman. It's just you install Podman Desktop, and then you click, 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 and you have everything working. For Linux users, we don't care. So it's not really a feature. It's more a non-feature. And for example, I have been using Linux for 20-something years. And now I do this presentation on Windows because some of the features are specially baked for Podman running in a VM and not for Podman running on the host. Meaning that when I was testing on Linux, I had things that didn't work. And the application is really, really, really meant for Windows and macOS first. And we have very few Linux users. And yes, so container engine. You see the little Compose here? So you can install Compose on it. So you can run Compose, but the interesting thing is that then from the container that you started by running Docker Compose, you can continue and do something that we hope is better. Yeah, so proxy connecting to registries and installing in a restricted environment, that's feature that we implemented in December, January, February. So that's the first. It came even before connecting to Kubernetes. This feature is that if you are running in a jail where you don't have access to internet, and we made this feature first. So really for people who want to run Podman Desktop and Podman in a lockdown environment in enterprise. For most of the users who are working remote, it's not a feature, but for enterprise it is. And you have a little, so you can choose between your Kubernetes context. And so in fact, natively you connect to all the Kubernetes that are in your kube config. So if you already have clusters, they will show up here, and you can select in which context you are working. And now I have a lot of time for demos. Okay, so there are some demos that I don't do live because it takes too much time. So, but there are some that I want to do live. So this is how you start the Podman machine in Podman desktop. And I'm sorry, but if I do this demo live, it will take 10 minutes, and I cannot show everything. So it's easy. There are certain circumstances where so Podman by default is running rootless. So it means that the Podman is started with a user, a basic user, not root. But in certain conditions, you want to be running Podman as root, and there is an option for that. And we made that for kind on Windows. So to run kind on Windows, it works better if you have a rootful Podman. Good. Hopefully I don't know. This afternoon, my rootful Podman machine didn't work yesterday, so I will not show it this afternoon unless I can fix it. Pulling an image. Let's see if the network is okay here. So, pulling an image. I will delete the Redis image. Up, and I will try put an image. And I have my problem with Docker not accessible today. That's wonderful. I like the live demos, you know, when you break things. Okay, so it doesn't work. I'm super happy. Let's do. Okay. When the gods of registries are with you, pulling an image is super easy. So I've never had a Docker registry refusing to download an image before this morning in this room here. So that's the big surprise. So, but yes, okay. So you can download image from multiple registries, and so when one registry is down, you can use another one. Quay is a cool registry for that. Next. So pulling an image. Starting a container. So I will not do the demo with this Redis because I killed it. Mais comment on change là? But let's take Nginx. So to start a container from an image, you know from, so I don't know, if you use the command line, you know, a lot of command line, you put that in a script, etc. Here you have a lot of options that are displayed in the starter container screen. And usually, these are things that you define in the image. For example, the port to expose, that's defined in the image, and you just have to validate. You don't have to do anything, and you should have something that works out of the box. And so now I have my Nginx working good. And I can interact with my container. When you go to the details, it's always open the log, first thing. There is a summary, which is not the most interesting thing. In the logs, if you click in the logs, no, Control F doesn't work today. No, if you do in the inspect, if you click in the content and you press Control F, you can search for things inside. That's a nice hidden feature. So that's, you can inspect the container. The cube thing is one of the feature I will talk more a little bit later. So from this container, you can create a pod, and basically the definition of a pod is a Kubernetes YAML. So when you create a container, you can directly have the YAML content to create a pod out of your container. And you can interact with the container. And last thing, no, not exactly last thing, you can, as the container is exposing a port, you can directly visualize what is running on this port. When you're running Podman, that's easy because it's localhost, the port. When you are running in OpenShift or Kubernetes, that becomes a little bit more complex. And you can, you have here a button to deploy to Kubernetes. And the context here that you can see here, it's depending on the context that you activate here. Okay, so here I can decide to deploy to OpenShift local, to developer sandbox. On OpenShift local, I have 2 profiles, and I have a microshift instance that doesn't exist anymore, but I can still choose it. Let's back to the slide. Starting a container, starting the Nginx container, building an image from a container file. Yes, let's do this. And normally, today, I am cheating a little bit. So here you can put another name. So you first have to choose a container file or a Docker file. So most often it's called a Docker file, but sometimes container file. Then Podman Desktop will take your container file and all the directory that are around. So if you are copying files, Podman Desktop has all the context to do the build. Okay, we will see that in the logs. but as I'm cheating, it goes very fast, okay? When you build for the first time, it's actually uploading the build context can take 1 minute or more because it's taking the Docker file and the directory from your local file system, and it's copying that to the Podman machine, which is in a VM, and then the build is starting. And here I'm cheating because it's already built, so I'm using the cache. I'm not sure you want to see that? No, you don't want. So, registries. So that's important. Where do I start? Yes, registries I will show in the app directly. So the registry, they are in the settings here. You have 4 registries that are pre-configured, or where you just have to add your username and password. For Quay, in fact, it's username and a token. And if you want, you can add your own registry. So if you have a private registry just for yourself or for your company, you can do that. And when you have added one registry, later on, you can, if the image name that you have, so if you built an image, if the name match the registry, then you can push it. For example, this one, my custom image, I can push it to a kind cluster, but I cannot push it to my registry. But this one, which has a name that corresponds to my Quay.io registry, I should be able to push to the registry. And then when I push to the registry, I can select between tags. Obviously, I take the tag that corresponds to the registry. And then, I haven't tried this today. Does it work? Does the network work? Yeah, I'm happy. It did work. So configuring, you can configure a registry. How many time do I have still? 5 minutes. Oh, yeah. You can push an image. We have done that. And next topic, 5 minutes to talk about pods. Oh, yeah. That's live demo. Okay? I have my pod. I delete my pod. Hop. Let's be crazy. So I have Redis. I select 2 pods. So to explain pods, as I live in Belgium, I was thinking of a metaphor that is implying fries. You want it? So in Belgium, you have 2 categories of people. You put the sauce on your fries, or you put your sauce on the side of your fries, But frites au tafar, they call it. And pods, it's a little bit the same thing. Is when you have containers that are exposing ports, you want that the application is exposing the port to the user. That's good. But the database, you don't want to expose the port of the database to the user. You want to keep it in an internal network. Same thing. In your fries, you expose the fry to your mouth, but the sauce, it's just for the fries, not for your mouth. So, but you cannot do it with fries. So you select your pods, and then you select the port that you want to expose externally. And the ports that are only required internally, you don't expose them. And here he is. He's working. Perfect. So, in the logs, you see that you have the logs of your two containers, the Python app modified and the Redis modified, okay? And can you search in the log? No, not today, okay. You can inspect the pod, okay? And here you can search in it. And you can see that it's exposing port 5080. Good. And you can copy and paste the YAML to create it from code somewhere else. Okay? So that's already cool. And you have the possibility to deploy to Kubernetes. That's for this afternoon. And here, if you go, that's where the application is still young, because if you want to connect, so now you want to see the app of your pod, you don't have access to it in this screen yet, okay? It will happen, but we have not done it. But in the summary, you can, I clicked on it too fast. In the summary, here you have the name of your containers. You have 3 containers. So there is one secret container that you didn't choose that happened here. And if you click on the container name, secret, then you are on the container. And this time, you can open the browser and we have the application and the increment is stored in the Redis database. So that's cool. And if you, so you have you can see your logs. That's good. And you can see that the container that I selected are now stopped, so I don't have any more container in the running outside of the pod. And my pod has been created, and my pod has three containers. And the last of them is an infra container that's ruling them. And Redis logs, you don't see things. I can show you. You can interact with the Redis database here. How many seconds? It's over, huh?
I mean, there's plenty of time. We need like 8 minutes, including QAs.
So I will finish that and then questions. So question, you can select containers to run a pod. We've seen you can generate the YAML to run a pod. Questions are, the last demo is you use the YAML and you start a pod.
far, I'm not convinced. What are your main 3 selling points that should convince me to switch to Podman Desktop?
You can still use Podman Compose. You can still use Docker Compose after that. Okay, so that's not a
selling point. You're just
no.
telling me I can still work with the same stuff.
Yeah. Okay. It's so when you do the Docker Compose, you cannot send the thing to Kubernetes. Kubernetes will not understand Docker Compose.
Okay.
So that's the first point, is that you have something that works on development, but then if you want to put it on production, the Docker Compose is not working. So you have, at some point, you have to do the translation from Docker Compose to something that is Kubernetes YAML. And that's where what we are trying to do is that this translation is as painless as possible. Okay. So and because you can use Podman Desktop with Docker. I failed to install Docker this morning, but that's another question. You can use Podman Desktop with Docker, and then you can use Compose with Docker, and then use Podman Desktop to take the state of your containers, to generate pods, or to generate kubeyaml, because you cannot run pods on Docker. That's the problem. But you can generate the YAML and then run the YAML into Kubernetes. So we support Podman, we support Docker, we support Lima at this moment. So 3 different container engines. And for Kubernetes, so we support remote Kubernetes engine that are in your kubeconfig. And we have more support to help you install OpenShift local, help you install kind, and connect to the developer sandbox. And that's what I will develop this afternoon, this kind of stuff. So the point is, do you want to deploy to Kubernetes afterwards or not? If you don't want to deploy to Kubernetes, you don't need. If you need to deploy to Kubernetes, and that's something that developers need to do and not the ops team, that's a very nice tool to make it easier. Voilà.
Just a point to his answer, to you, that Docker Desktop is actually, you have to pay for it, so this one is free.
If it's not private use.
Yeah, so if you want to use it in a company, you have to pay for it.
Yes. The licensing sucks.
Until you reach a certain number of employees.
No.
The moment you run a conversion, you pay.
If you want to use it commercially, you have to pay, basically. So it's done.
And Docker always runs root containers, and Podman runs rootless.
Yeah.
I guess it's a problem, but same way in a VM, I don't think. Like, why would that matter?
For some people, it doesn't matter.
Yeah. You're worth running it.
And for example, if you want to run, the standard run, so the Docker IO Redis or Nginx image on OpenShift, for example, it doesn't work. So OpenShift is putting constraints much higher than Docker. So containers are running fine in development, and everything is okay. And then you push to production, and suddenly the container is not working. So it's to have this information, this feedback loop, be closer to development. That's a nice tool, and that's something where the usage is different from the Docker or Kubernetes extension in VS Code or in whatever editor you are using. It's not exactly the same usage. The Kubernetes extension is not something that brings you from container to Kubernetes. Yeah, that's a tool that just to do this transition. To do this, I I work on containers. I have everything that I want on containers. And that what do I need to do to move to the next step? Voilà. Good answer.
Perfect.
Another question?
Do you have a roadmap or new features you want to add?
New features that are coming?
Yes.
Stability. That's for me. That's the most important. So we have been building features like crazy in the last month. So the project is 1 year old since February or March. So it's very, very, very young, and it was going very, very, very fast. So stability, so end-to-end test to know that when we build a new feature, we don't break another one. So that's, for me, that's the most important one. And then for now, the OpenShift local extension, it's the first iteration. For Kine also, it's the first iteration on them. So that's we discover all the edge cases that make things break at some point. And also things like, now I have my pod running, I want to have the button to open my application directly, so to have things even more simple and less hidden. There are some features that now are just, it's here, but you have to know. And I would like it to be more simple. And voilà, that's quite a lot already. And I know that what is coming now is the welcome page has been reworked, because now it doesn't. If you look at the welcome page, it doesn't fit in a screen. I have Podman that takes all the room, but the rest is. So okay, here I have a big scaling factor to display in a big screen, but this welcome page was okay when there was only Podman, but now that we have more things, that's a problem.
Yeah, I just checked. I was right. So
What?
it's free unless you reach 250 people and 10 million in revenue. So you can use it anyway.
Well, we can.
Another question?
So maybe a quick one. So what's the long-term plan for Windows people to convert them to and make the graphical interface work for them actually, or let them use the terminal at some point?
So the terminal interface is there. So anyway, we install it. Huh? So you use it, you don't use it. It's your choice. I will not choose for people. I've been using the text interface for years, and I learned things about containers by using this app. Because there are things that are more displayed. There are things that are also hidden. Because choosing to display containers, pods, image, volumes. You select what you have some visualization, but for example, there is no deployment. So in Kubernetes, deployment is even more central than pods, and you don't see them. You don't see the secrets or other things. So there is a selection and a simplification of what you need to know. I find it's really interesting to enter the machine and to say, okay, that's the important point. I will focus on them, and the rest we'll see later. But I don't know. Command line and Windows, that's complicated. So I'm command line user for years, and now I have cmd.exe, PowerShell, Git Bash, and some of the commands land in one of the the terminal and not in the other, it's getting me crazy. So the terminal experience on Windows is anyway is a problem. Just okay, terminal, open a terminal. Which one? CMD, PowerShell, Git Bash, something else? I'm using this terminal that has all of them, but you see, it's what do I want to use now? So that's complex. So this afternoon, I will try to break things on Kubernetes, OpenShift Local, Developer Sandbox, and all of that, and it will be fun.
So let's make it
Yes, and you can see our
Hello, good morning everyone. I'm thrilled to be here today to talk about a topic that is crucial to the health and performance of Kubernetes applications and applications in general, testing observability features. As developers and DevOps engineers, we understand the importance of monitoring our applications, diagnosing issues, and ensuring that our alerts are accurate and timely. Today, we'll delve into how we can achieve this using Prometheus, alert managers, and various testing frameworks and libraries. A little bit about me. I'm João Vilaça. I work at Red Hat. In specific, I'm contributing to the KubeVirt project. I don't know if you had the chance, but in the first floor here, we have a small booth where we are giving some demos and giving some swag. So if you have the chance, please stop by. I started working on a tool of KubeVirt named Hyperconverged Cluster Operator, but then slowly I started having more focus on monitoring and observability features across the all components. So, the outline for today. We'll start by setting up and seeing how to do a test environment, how to test metrics, then moving on to alert testing and how to ensure that they are actionable, relevant, and real alerts. And in the end, I'll show you a small demo of how I did everything together. So let's start with setting up the test environment. First, we need to understand what the test environment should look like. It needs to be obviously a controlled space where it can simulate the conditions of a production environment, obviously. But we don't want the risk of causing disruptions to our actual users. And in our tests, we'll need to create and delete a lot of resources, remove permissions, cause network problems. So this is where the concept of a disposable local cluster comes into play. A disposable cluster is nothing more than a temporary Kubernetes cluster that we just create for the purpose of testing. The beauty of this approach is that we can spin a new cluster whenever we want and whenever we need to run a test, and we can just tear it down once we are finished with it. This ensures that every test of ours starts with a clean slate, and we don't have to worry about any leftovers from previous tests and weird permission changes that we might do to test our components. Spinning up a cluster can be used with a lot of tools. Some of them easy to use and available right now are, for example, Kind, which is Kubernetes in Docker, Minikube, MicroKatos, or any other. On KubeVirt, we actually have this cool tool already. I literally use this every day when I'm at work. And it already creates a cluster and has even a flag and sets up everything Prometheus related. So I really like it. And in the automated tests, nowadays we don't use it. We provision full clusters. But that's more like, I see, like a bonus for when the projects are more mature. And small projects that are starting, I don't think they really need it at the beginning. So let's start now with metrics and events. Metrics are obviously the base of observability, right? They give us insights on how the application is behaving, and they help us diagnose issues. And we'll explore how to test those metrics. I put here the question like, are unit tests enough? Obviously, it's a dumb question. Of course, unit tests are not enough. But in the ideal world, everything will be fully tested, right? But then again, we can't have everything. And we know time and workforce are limited. So in the end, I guess, at least in the beginning, unit tests are kind of enough. In my opinion, it's more important to start with end-to-end tests for alerts. And usually, a lot of our alerts already use metrics for the calculations. So if our alerts are working correctly, we have some degree of confidence that the metrics they are using are working correctly, right? And but even though we can start simple, and most of the times, like the simple things are the ones that end up saving us the most time in the future. And when we talk about metrics, it's very important to first validate that we follow the right naming conventions and we have the correct labels. And if possible, checking if the metrics are prefixed with a component name, so that later on we can easily find out where the metric is being created and just more quickly trace it back. And add unit tests for functions that update those metrics, and in the end of the test, validate that their value was correctly updated, as we'll see later on the demo. Now, let's start with the alerts. One of the main concerns in this topic is that we don't want to be flooded with false alarms or miscritical alerts, right? So we'll discuss how to ensure our alerts are actionable, relevant, and they are real. And we'll also cover how to configure them correctly and ensure that they react to the appropriate triggering conditions. This is probably the most known quote in the area, and if you work with alerts, you already probably saw it, that every time the pager goes off, I should be able to react with a sense of urgency. I can only react with a sense of urgency a few times a day before I become fatigued, and every page should be actionable. This is taken from the Site Reliability Engineering book, so it's like one of the Bibles of observability, right? And we have to be aware that an urgent alert might actually wake up someone in the middle of the night. And this is even more important when we are producing software for external clients. We don't know how many people on duty they will have. Actually worked on a small company before, and we were two people managing infrastructure, and we didn't have someone already ready at all hours of the day, right? And since we had clients on the other side of the globe, if we had an alert in the middle of the night, one of us would need to wake up and look at it. So it better be a real alert. So how should an alert be configured? It should have an owner, a contact person that it's basically able to quickly understand the problem that created the alert or the process it refers to. Sometimes it might be the developer of the feature, other times it might be someone from a monitoring team. So this is really important because sometimes we don't want to start with something that we don't know very well and knock your head off and then lose valuable time. And as in metrics, we should be able to quickly identify the component to which the alert refers to. For example, if we have a Kubernetes operator that is managing, for example, resources on IBM Cloud, we might want to have an alert like IBM Cloud is not available. So we want to identify which component created the alert so we can quickly understand where it came from and go there to navigate the logs and try to understand in more detail the problem. Also a summary and a description, and I think those are actually pretty straightforward, but we should also have a link to a handbook, which we'll see in more detail in the next slides. Usually for severity, some people use different severity levels, but Prometheus actually recommends these ones. And they are useful to distinguish like which actions we should perform for each alert and to sort priorities on them, right? For critical alerts, those are usually the ones that will page people in the middle of the night. the warning alerts, we sometimes just want maybe to create a ticket that should be looking into the next day. They are usually useful for some component is reaching critical memory. If you don't do anything, in a day or two, they will reach a critical state. And info, we usually don't really perform any immediate action. We just also create a ticket that goes to the bottom of the line. About the alert runbooks, I think those are really the important part, because they serve as a comprehensive guide for the cluster owners or the operators. And they should provide a step-by-step instructions on how to handle the specific alert. Like, you all know that if you don't provide these handbooks, usually owners or operators will need to go through a lot of documentation pages or their personal notes to understand how they can debug and fix the problem. And this always leads to losing valuable time. Usually that time also means losing a lot of money, right? And even worse than that, sometimes we force them to rely on memory or improvisation because they will handle some related issue in the past, and that will also lead to mistakes and more delays. So, how can we test the alerts? In our tests, we should make sure that all the alerts include all the mandatory fields that we said before, that each handbook URL link is valid and the handbook actually exists, that the alert includes a reference to the instance or pod. It might be like the name of the component or really a label about the pod or even in the description. And the alert is triggered when the expected conditions are met, right? And then again, most of these steps are actually very simple, but as I said, for metrics, might just save us a lot of time and headaches in the future. So now let's put this theory into practice, and I'll try to show you a small demo that usually goes very badly. So, to start with, I have here the creation. I don't know if you can see if I should increase, or do I not want to increase? Can you see, or is it better to increase?
Better to increase.
Let's see. Didn't even start already, first issue. Maybe it's good. So, in our project, we want to create the metrics, right? I actually have this file here that I should start with. So, this is a simple operator for Kubernetes. I legit didn't have no logic at all for now, just some simple metrics and alerts just to show you how you can start with, right? And from then, I used, in this case, Kind to create a new cluster, and I just installed Prometheus. I'm doing this locally, but obviously you can follow these steps on a cluster you have for testing. It's even possible to do it on GitHub Actions or GitLab. So really simple steps that you can easily do in 5-10 minutes. After having the cluster, I then created my metric. I have here the controller label to refer to the operator. We are now looking also, for example, to have stability levels that will allow us to deprecate metrics in the future. So all these labels are really important for you to put some time into thinking about them, and because these are the kind of things that will help you, your team, and your customers. And then for example, for these metrics, we have here the reconcile loop of the operator. For those of you that are not familiar with operators, it lets us create a resource, a custom resource on Kubernetes. And then, for example, when I create that resource, it runs this reconcile loop for me to perform any actions. Imagine that here, as I said before, I want to work with IBM Cloud. I might want to create a machine on IBM or a route, something like that, and this is the place where I will be doing that. And for example, here, whatever the logic is, I want to increment this metric that will tell me how many times the reconcile loop was created. And as I said before, here we can start simple and write the tests for our metrics. In the first step, we can start with the easy validation that, for example, the metrics follows the Prometheus conventions. And we list all the metrics, and then we'll lint the metrics. Here I'm using PromLint tool, which already brings a lot of validations that, for example, the metrics have all the necessary structure. For example, counters should not have the total keyword at the end. And as I said, this is really important to take a look in the beginning when we start adding metrics. In KubeVirt, we had a lot of developers adding metrics and without any validations. And in one component only, this is not here. Okay, no. I lost it. Good. Let's see. So what ended up happening is that when we added the linter, we had all these issues. Non-Instagram, non-summary metrics should not have the count suffix, and you see those are a lot of errors in terms of units and so on. So, and now we saw before that we are adding stability levels. Why are we adding that? Because this project is used by clients. And which metrics are clients using? Those ones that we created before. So we can just simply go there and rename the metrics because they are using them and it will cause them a lot of trouble. So we are now thinking about we should deprecate these metrics for 2 versions, create new metrics with the correct names, warn the customers that these metrics will no longer be supported, then trying to see if they are already using those metrics, not causing them issues, and this will take a lot of time. So, and you saw that really it will take like very few lines to call Prometheus linter and save us all from this kind of troubles. But that's life, and that's why we are trying to now expose these issues that we have with the community and writing some best practices so these problems don't happen again, right? So moving forward, here it's the unit test for the metric, right? We get the initial reconcile value count, and then we run the reconcile loop. As you saw, it was very simple, so it's obviously updating the metrics, but in the future, your logic will be much more complex. But even though in the end, you, for example, in this case, expect the initial value to be added 1, and that will be the final value, right? So pretty simple stuff. From there, we move on to, for example, recording rules. See. So this is where we are creating registering the rules. So for this project, I created two simple recording rules, right? The first one, the number of operator pods in the cluster, which is simply query for Prometheus, which counts the number of pods up in the cluster of that type, and also the number of ready pods, which is the sum of the up pods in the cluster, because this up metric will have the value 1 if the pod is ready to be used, right? And also, you can notice here that some of we are also already trying to use stability levels on the alerts. For example, alpha, here is just an example, but the idea is to show that this is not like fully tested and it's still being worked on and added. From these recording rules, we are building our alerts. And one of the most important alerts to start with is obviously testing if the operator is down or if the operator is not ready. We make use of the recording rules we saw before. If the number of pods, operator pods in the cluster are 0, we'll be triggering the alert. And if if the number of ready pods is less than the number of pods, we'll give the alert test operator is not ready. For those, we have also some validations. For recording rules, we are linking the metrics linking the recording rules as we did for metrics, because they should follow the same conventions as before. And then here, for example, I want all recording rules to be prefixed with the name of the operator. And also the same for alerts that should follow Prometheus conventions. And actually here, I also put the link here that I said before that we are trying to achieve, adding the best practices for observability on operator SDK. So a lot of these validations come from there, right? Alerts must be in Pascal case format, they must have an expression, we are validating labels, validating annotations. So just following the recommendations there. And these are basically the unit tests. I could have run those just to see that as a good developer, I follow by the rules I created. This one for the metrics. It will be very funny that it failed. And this one for the rules, pretty simple stuff. So now, moving forward for the end-to-end test, that's what we want to know, right? I already here have a cluster. Actually, I see that I have the resource created and the pod, but on running, it will clear it all. I'll start running because it takes a few minutes, I think. So, and let's see. For metrics, we are doing the same thing. Here some setup, deploying the operator, then port forwarding the Prometheus service so that we can access it locally, and deleting any previous resources that exists. And our test says that we should increase the test operator reconcile count when the reconcile count is run. So we just get the initial value for the test operator reconcile count, and we create a new resource. As we saw before in the reconcile loop, any resource that is created is supposed to update the metric. So in the end, we know that eventually, when getting the metric, it should equal the initial value plus 1. This is a real simple test for metrics, but as I said before, it makes sure that everything is working as supposed. We saw that this is very similar to the unit tests, but in unit tests, it's easier for us to know that the metrics are updated. Here, it's more tricky because it has a lot of also other operations before, because we need to make sure that Kubernetes is actually passing the right events, that is being caught by our operator, and then later executing the reconcile function correctly. And we have reconcile count, but we can have number of resources created, number of resources deleted, anything we want, right? And for alerts, we first have the verification I mentioned for the handbook. We are checking that the handbook URL is available. I created just some GIST on GitHub for the purpose of this demo, and I can actually show because I copied it from one of our handbooks, cleaned up some stuff. But let's see, because it's also useful to know what a handbook should look like. First, we have the meaning of the alert, that supposedly these alert fires when no test operator pod is running the cluster. the impact that this alert has. Sometimes in KubeVirt, the operator might not have like a big of an impact because the operator is not responsible for the virtual machines. But if the alert is like virt controller is down, then the users might start to have a problem because virtual machines are running wild in the cluster and nothing is controlling them. And then we have all the diagnosis steps, and here we should have clear steps that in the end we understand very correctly what the problem is. So moving back to the tests, we are now following the same approach more or less for metrics, deploying a new test operator, and then we are making sure that the test operator is thrown when we want it, right? And in this case, for example, we just scale the deployment down to 0, and since we have no pods in the cluster, we verify that the alert is being triggered. In this case, pending is enough for me because you might want to have a delay on the alerts, just throw the alert if the condition is met for more than 5 minutes, for example. But if I see if the alert is pending, like the condition was triggered, it's just waiting for those 5 minutes, I think the alert is working fine, so I'm okay with it. And for the operator not ready, I just come here and set a random image, which might mean, for example, that the repository is not available, as happened earlier in the other demo. So it's a problem that sometimes we think, oh, this never happens, but it happens more than it happens a lot, yeah, that's what I want to say. And we then validate that the alert is then thrown, once again, if it's firing or pending. And as the time goes by, we start adding a lot of alerts. For example, we might want to see if, oh, it failed. If so, I'll see again. We might want to see if the operator is creating the right resources on Kubernetes. And for that, it needs permissions. One of the things that we can do is just go there, just delete the RBAC permissions, and see if the correct alert is triggered, saying that this permission does not exist anymore, and you should look into it, right? So that's one of the things that we test. We can test, for example, for the HTTP requests, if they are failing. That's actually a metric that Prometheus already gave us. So the number of things you can alert for is up for your imagination, actually. And just to finish, I want to present like this really useful tool. We don't use it on KubeVirt, but I use it on my master thesis, which is Chaos Mesh, and it's really cool. It's really simple to use, and it allows you to create a lot of problems in your cluster. For example, deleting pods, causing network issues that might be a lot of latency, requests being dropped. You can cause CPU and memory issues. You should really take a look. It's simple to use, simple to configure, and it has a lot of potential for the unit testing. So to wrap up, I just want to say that it's really important to add observability features. It really helps us. Usually when we start projects, we tend to overlook those kind of things, but they end up being very important and to help us in the future. And also important that they are actually working fine. As I said, we don't want our DevOps and the clients to be waken up in the middle of the night just to see that the alert was not real, or we don't want to have bad problems happening in the cluster, but they are not alerted for, and they are losing money and they are losing clients. So those are the main takeaways. So that's it. If you have any questions, feel free.
You mentioned you would deprecate those metrics that you would conform to the rules that clients may be using and eventually remove them. Why would you ever remove them?
Yeah, because those metrics are not up to standards, right? And the idea here is to when we have the stability level deprecated, we will add a flag in the help text saying they are not. Because if we keep metrics that we want to update, we'll have a lot of more things to manage in the future, right? And we really have already a lot of metrics, and it's hard to keep up with them. We are also trying to add tools to generate documentation and to centralize the metric creations, but there are so many of them. And if we have 10, 20, it's manageable, right? But when we get to the hundreds, we have a lot of components that becomes a problem. And maybe it's not a thing, as you said, we cannot remove them maybe in a version or 2 or 3 because those problems happen. But eventually in the future, I think we will need to end up removing them, or else it will be unmanageable. Because even it's an open source project, right? And people come and go. And if we don't do anything about them, they will eventually be forgotten. And nobody will know why do we have this metric and we have another one similar. So that's why it's really important to validate them in the first place. Yeah. I don't know if you might not agree, right? But it's my view on it. So, any more questions? Please.
Do you have any recommendations for tracking constant errors?
For? Yeah. Mm-hmm.
But if I want to have more granularity for the errors.
Mm-hmm.
Please repeat the question.
Sorry?
Please repeat the question.
Yeah. So the question was if how to create metrics for reconcile errors. So basically, that example was very simple. But imagine you had an error. Usually exit the reconcile loop with an error, right? And there I have just these. I have these just operator metrics. So reconcile count, but I could create a new one like reconcile error count. And in our loop here, I perform some operations that throws an error, and I just create that new metric like increment reconcile error count. No, that was.
Well, like not all the errors worth alerting, I guess.
Sorry?
Not all the errors worth alerting for the
But this. Yeah, but you can have create any metrics you want, right? You might want to have an error that was you could not connect to an external provider. An error that's just you can create any metrics for the granularity you want, because metrics are really cheap, and you can and you should create the metrics you need to then help you debug actually. But then when creating the alert based on those metrics, we should be more careful, right? Some of the errors might not be worth to alert for, because it might come from user configuration, that it was not able to create the resource with the properties it shows. So that might be like a warning or an info alert for them. But yeah, my advice would be create all the metrics you want, because if you think that information is valuable, create the metric. The alert, you should be a little bit more careful. Yeah. Any more questions? So I think this is it. Thank you everyone for being here.
All right. Yep. Okay.
So, John works in Red Hat in the storage team, which is the Stratus daemons, which is written in Rust, and he will be talking about the favorite language of every Rust.
Hi, everyone. Thanks so much for coming today. So I just wanted to give a little bit of background on why I put together this talk. And essentially, asynchronous programming is something that's emerging in Rust. And when I was learning how to do asynchronous programming, then I essentially bumped into a lot of corner cases where it became a little less apparent how to proceed. And so while the ergonomics are quite good, then I kind of wanted to put together a talk that would basically talk about how to get started from ground zero in asynchronous programming in Rust. So the overview of the talk today is we're going to start by talking about the state of asynchronous programming in Rust. So basically just like language level support, what's there, what's in external libraries and that sort of thing. We're going to talk about asynchronous programming fundamentals. So we'll talk a little bit about the architecture, syntax, and why that matters. And then we're going to do a quick case study of a modified read-write lock that we implemented in storage for our use case. So the state of asynchronous programming in Rust. It's designed to handle use cases like asynchronous I/O and network operations. So in general, anything that you would need to do asynchronously, the framework is designed to handle that. So long-running, blocking tasks in the background, that sort of thing. I wanted to give a couple of definitions because in asynchronous Rust, we talk a lot about tasks and futures. And tasks are kind of like green threads. So if you're familiar with Java or Go, you're familiar with this concept. It's basically multiple green threads can be served on a single OS thread in parallel. And futures are basically the handle that you can use to pull and access the final computation, similar to kind of JavaScript promises for those of you who are familiar with JavaScript. So one note is that Rust doesn't really have the same kind of level of runtime that Go does, so it can't preempt threads like Go can in their asynchronous implementations. So it requires an API design that builds in yield points anytime that a green thread can't make progress or a task can't make progress. And futures also require an executor to handle driving them to completion. So in general, you need some sort of executor to kind of drive the asynchronous workflow. So that's a lot of information, but we'll dive into some of this in future slides. So the language level support is really just kind of async and await at this point. So what async does is it's a keyword that you basically attach to a function, and that turns that function into a future. Await basically allows you to await on a future to complete. And while it has the same kind of semantics as blocking, it's awaiting in a non-blocking way. In terms of the standard library support, then there are a number of data structures that have been added into the standard library. And we're going to talk about some of these in more detail, but the one I really want to call out is the future implementation. So this is the trait that basically is the building block of asynchronous Rust, and you basically implement this for all of your future needs. So in terms of external library support, and then basically we have futures RS, which provides utilities for working with futures. So that's going to basically be combinators for basically handling multiple futures in parallel, that sort of thing. And you also have an executor, which, as we mentioned, is required for actually executing the futures. Tokyo is basically a library that's built with more functionality built into it, and it has a compatible executor with futures RS, so the two can be used together. It provides a runtime for asynchronous programming. And basically what this runtime includes is a bunch of async utilities like an I/O driver, a scheduler, a network API, synchronization locks. So it's really kind of aimed to really cover a lot of the asynchronous use cases that you might bump into with asynchronous programming. And then I figured I should also call out async standard, but it does not have a compatible executor with Futures RS and Tokyo, so the two generally bump into problems when used together. It basically aims to provide a similar API to the standard library, but it's all asynchronous. So this is becoming more popular for people that want to do kind of asynchronous standard library operations. So with all of that out of the way, we can talk a little bit about the fundamentals of asynchronous programming. So first, we're going to start with implementing a future. And consistently, this seems to be the thing that a lot of people struggle with the most in asynchronous programming. I put up the definition of the trait for the future, just so that we could go over it in a little bit more detail. And the basic idea is that you just kind of define what output the future should give, and then you have this poll method. So what the poll method essentially does is it basically polls over and over again as it's woken up, and basically you return either that you're ready and you return the result, or you return poll pending, and it goes back to sleep until it's woken back up, and it can make more progress. So one note is that you should never block in poll, so that can cause problems, and we'll get into that a little bit more in future slides, just why you should never block in poll. So this is an example of kind of what happens when you're not ready. So when you're not ready, then you basically have to register this thing called a waker. And so the waker was listed on a previous slide as something that's in the standard library support. And what the waker essentially does is it's a way to signal to a sleeping future that it's ready to progress. It's ready to make another poll invocation. And so when you basically put the future to sleep, then you essentially have to register the waker somewhere to be called later to wake up the future. And basically then you return poll pending. So here is an example of kind of when you would wake a future. So here we have waker.wake. It's pretty simple. You basically call that when the future is ready to make more progress. So something always needs to call wake when the future has reached a state where it can progress, because otherwise the future is put to sleep indefinitely and will never wake back up. And so one of the common misconceptions or difficulties learning asynchronous program is kind of where do you call wake? And so I've put a few examples of kind of where you could call wake. It could be in a spawn thread in the background. It could be in the drop method on the return data type from polls. So say you return a handle indicating resource acquisition. In the drop method, then you could theoretically call wake to signal to other sleeping futures that they're ready to progress now. The waker could also be sent using a channel across to another thread, where you basically have a thread in the background listening for events and determining whether the sleeping tasks are ready to make progress. So there are a lot of options, and it's really up to the design of the developer. So some important notes on futures are that creating a future does not start its execution. A lot of people expect it to, but it doesn't. So it must be either polled or awaited to kind of start execution. However, using Tokyo spawn will immediately begin execution in the background, so that's one case where you can start it immediately. Poll also needs to handle wake-ups where no progress can be made. So in general, you may expect that poll only needs to handle cases where waker.wake has been called explicitly, but there are scenarios where it can be woken up due to side effects and where no progress can be made. So your poll implementation always needs to be able to handle that. We can now move on to kind of sort of the Tokyo runtime basics. The runtime contains an executor and scheduler. So that's where a lot of the I/O code, like kind of the functionality for ePoll that you would get asynchronously in Tokyo is built into. It has multiple runtime backends, so you can choose either a single-threaded backend, where basically all of the tasks are interleaved with each other on a single thread, or you can have a multi-threaded backend for true parallelism. And futures are spawned as tasks, and multiple futures can make up a task. Multiple tasks can be served on a single thread. So the end result is that blocking in a future can stop other futures from progressing, and it probably makes a little bit more sense now why you should not block in either poll or in async function, because that could theoretically stop another future that is ready to progress from progressing. So there are two notes on the blocking aspect of things that I just want to call out, which is that async functions can use blocking mutexes as long as they are not held across awaits. So basically, you cannot acquire a mutex, then do an await, and then release the mutex. So as long as you're just acquiring a mutex for one single statement that is not across an await, that is okay to use blocking mutexes. And blocking mutexes are actually common in poll implementations, but they can only be held for the execution time of poll, because the general thought process is that if you acquire a mutex and then drop it as soon as poll completes, poll is supposed to be very short running. So if it's only acquired for that scope, that is equivalent to non-blocking from the standpoint of asynchronous programming. So there are two types of threads. There are blocking threads and core threads. So the core threads are the kind of OS threads that we've been talking about that can serve multiple asynchronous tasks on a single OS thread. Blocking threads are kind of a special case where they're used for areas where you cannot get around blocking, and they basically assign a single task to the blocking thread so that it can block without causing any other task on that thread to kind of stop progressing. And so that those blocking threads we'll get into a little bit more, but that's one way that you can block in asynchronous programming. I also just want to call out that the Tokyo documentation is very thorough, so please take a look at the glossary and the more advanced topics in the tutorial, because they'll give you more of a working knowledge of some of the terminology and kind of code that you can write with asynchronous programming. So we're just going to quickly go through syntax and common usage. We've already kind of covered async and await, but that's one thing that I just wanted to mention here. We also have spawn, which we've referenced. And so the way we can think of spawn is that basically we have this long network operation. And so we call spawn on this asynchronous task. And basically it spawns in the background and starts immediately executing. We do a lot of other work that we have to do before we can handle the response. Then at the end of that, we await, handle the response. And that's a great example of kind of a basic asynchronous workflow. Spawn blocking is very, very similar, but basically it's for blocking operations. And so this is going to spawn this task on a blocking thread. So you can basically do all of your blocking here. And so it's a similar kind of API. You spawn the blocking network operation, you get the handle, do other work, and then await and handle the response. So block on is kind of the inverse of spawn blocking, where from that we're calling basically a blocking function from an asynchronous context. Block on allows you to basically call asynchronous code from a blocking context. So in general here we have an example where we basically want to make a blocking call, but then after that we want to evaluate a future. And this is assuming that we're calling MySync function from a context where it is safe to block. So we can call the blocking call, and then we can basically get the asynchronous API, and then block on it so that we block until it's ready, because you can't use await outside of an asynchronous function. So you would need to block on the asynchronous code. This would evaluate it asynchronously in the background, blocking until it's complete. join all is kind of a great example of spinning up a bunch of futures in parallel and waiting for all of them to complete. So here we basically have a vector of futures, so an arbitrary number of futures. We pass that into join all and await on it, and then when they're all done completing, then we can basically iterate through all of the results and handle them. Select is kind of turning that on its head, where we basically have a couple futures, and we basically wait until the first one returns. And when that first one finishes evaluating, then what we do is we basically handle the result of whichever future evaluated first, and we cancel all the rest. So the previous one was kind of waiting for all of the futures to complete. Select is waiting until the first future completes. So hopefully that gives you a little bit of kind of an overview of basic syntax usage, kind of common functions that are used to handle futures. And now we're going to dive into a case study of a modified read-write lock that we had to implement on our team. So the use case is basically that we had a table of data structures that all need to be locked independently. And the IPC mechanism that we're using requires fetching read-only information from all data structures at once. We initially considered locking each data structure individually, but that scales linearly in terms of lock acquisition time. And we began to notice a slowdown when we were fetching these properties. And so we ultimately decided that we needed to design a synchronization lock that handled our particular use case. So we basically need to handle a single read lock on an individual element, a single write lock on an individual element, an all read lock on all elements, and an all write lock on all elements. So we're going to actually dive into a little bit of code here. So I've highlighted kind of the important sections here, but basically you'll see we have all our sum lock, and in that we basically have a lock record, which is basically keeping the state of what is locked at any given moment. And we also have this table inside of a mutex, and that's keeping track of all of our individual data structures that we want to lock. So we basically have an all read lock kind of field here, and what this is an integer because we can have an arbitrary number of all read locks at the same time, as long as they're not conflicting with an all write lock, for example. We can only have one all write lock at a time, and we can have as many single read locks on an element at a time as we want, mapped to which element is locked. We can also have one write lock on each individual element, so we keep track of which element is locked and have exactly a count of 1 for those. So as you might notice if you're familiar with Rust, this is upholding kind of the mutable, immutable reference requirement. So basically we can have all of them read locked as many times as we want to, or all of them write locked exactly once. So this should look very similar to references in Rust. Next, we kind of have this implementation. We're going to dive a little bit into acquiring a single read lock on an element. And as you can see here, we basically just kind of create a future, and then we await on it. So this is a great example of the kind of async await workflow. We create a future and then await on it, and that's really all that this does. So it gets a little bit more interesting when we actually get to the future that we are awaiting, and that's the sum read future. So I've highlighted that this is the poll definition right here, so we're actually going to see a more complicated example of implementing the poll method here for the future trait. And I highlighted the acquisition of the mutex mainly because this is a great example. We're using a blocking mutex here, and because it's only acquired for the length of poll, it is okay to use this. Next, we kind of check whether we have a UUID or name that is registered in our table of data structures. And if we determine we don't have anything with that name or UUID, what we essentially do is we basically return that we're ready and we found nothing, but we also above that call wake. And one of the reasons this is important is because basically we've determined that we're done with our work, but anything else that might conflict with this read lock needs to be woken because now it can make progress because we have finished our read acquisition, so we have to wake up everything that's been put to sleep in the meantime. If we do find that something has this name or UUID in our data structures, then, but it conflicts with another lock that's already acquired. As you can see in this next slide up on the top right, then we basically add a waiter, and what we do with that waiter is we store the waker so that we can later call wake on this for it to make future progress. And then we return poll pending. So this essentially puts the task to sleep. And if we determine that there are no conflicting locks below in the else block, then what we can do is basically register that we have acquired a single read lock on this element. We basically get a reference to that element using unsafe code and put it in this kind of sum lock read guard, which some of you might recognize if you've worked with mutexes before in Rust. This is essentially a data structure indicating the lifetime of this lock acquisition, and we can access the individual data structure from this guard. So one thing that I just wanted to call out about futures is that when you drop them, that is generally considered canceling a future. And in this case, we have to augment the drop method a little bit for the future, mainly because if you're just canceling a future and there's no state stored in an intermediate place, then you can just drop the future and it'll be canceled. But in this case, we're storing things like what's waiting for the lock in our all or sum lock. And we basically have to have this cancel method to essentially clear out all of the intermediate state if we drop the future. Because say we drop the future and then it doesn't clear out all of that intermediate state, we could bump into a place where basically the lock can no longer service any future requests. So always be careful about the intermediate state that you're leaving in your asynchronous infrastructure. For the sum lock read guard, then this, as I mentioned, kind of indicates the lifetime of the lock acquisition. And as I mentioned as an example of where we can call wake, this is a great example of returning sum lock read guard from the poll method and then calling wait in the drop method. That was one example that I gave. And what we do here is we remove our record of the read lock, and then we call wake, basically saying we're no longer holding on to the read lock. And so wake up all of the lock tasks that conflict with this, because they can now make progress and potentially acquire the lock. So that was a lot of information, and I just kind of wanted to go through a quick kind of series of closing thoughts about asynchronous Rust, because as you can see, the design definitely requires some knowledge of the implementation to do it right. So some of the benefits are that the highly parallel nature of asynchronous Rust allows very good performance on very few threads. So in general, if you are doing a similar sort of workflow without asynchronous Rust, you'll usually be required to have many more threads kind of handling that same workload. And with asynchronous Rust, you can actually have those tasks kind of executing on fewer threads, and it gives you kind of an ergonomic way to interface with that. It also has support for many types of combinators and asynchronous workflows that are already built into a lot of the libraries that exist, so you don't really have to build everything yourself either. The design and documentation is actually very good, and so in general, I'm usually able to find answers to questions. Beyond that, the community is very helpful. And Rust's kind of promise of fearless concurrency also extends to async code. You're going to get all of the benefits of type checking, lifetime checking, all of that kind of stuff in asynchronous code as well. some of the drawbacks that I just wanted to mention is that asynchronous programming requires care. So as you see, it can be very, very detailed, and it can take a lot of thinking about the architecture, where you're blocking, when you're blocking. So an OS thread architecture can be used if requirements don't necessitate async. In general, it's not bad to just use OS threads, but if you're looking for performance, then you know you probably want to go towards the asynchronous side of things. Lifetimes can also be harder to manage in asynchronous code. So asynchronous code has kind of the problem that we have multiple threads operating. And so in general, we assume that a lot of the time, if you have a lifetime, then you basically, it has to be static. And so it gets a little bit harder managing lifetimes. And deadlocks and hanging can be a little bit harder to debug. There are cases where you have tools like Tokyo Trace to kind of help you out, but it can be a little bit difficult. So with all of that said, thanks for attending. If you're interested in looking into the implementation a little bit more, I've linked the repository where our modified read-write lock lives, and I hope you have a great rest of your time at the conference. So the question is whether I think asynchronous Rust could help in kernel space to solve some I/O problems that have popped up. And so in general, I've heard a lot of discussions. I'm also involved with the effort to put Rust in the Linux kernel. And in general, I've heard a lot of people being very hopeful about asynchronous Rust in the Linux kernel. One of the things that I think I've seen work happening on is basically building an executor that works in kernel space. So as I mentioned in the talk, one of the major challenges is that you need an executor to actually handle the asynchronous tasks because of the architecture. So there basically has to be some work on basically building an executor that works in kernel space. And that may be merged by now. I'm a little bit out of date on my information, but that's one of the things that's popping up.
Were you addressing the Cisco async I/O?
Yeah. Okay.
I have a question similar to that. Is there an executor that works directly without an operating system?
So an executor can work without an operating system. So in general, the question is there an executor that works without an operating system? And in general, there are executors that work without an operating system. So I think I've heard of people implementing executors even in lower level situations than the kernel. So it is possible. Rust is a pretty low level language. So as long as you kind of satisfy the executor requirement and the trait requirement, then you can basically implement your executor wherever you want to. The problem gets a little bit more complicated when you're dealing in environments that don't actually have an allocator, and that's where you have to get a little bit smarter about how you're designing your executor, because that can get a little bit complicated. Sure.
Just for the record, Embassy is the one that works on embedded systems and doesn't require any allocations. So
Okay. All right. Okay, I think that's it. Thanks so much.
maybe. Test, test, test. 1, 2, yeah. It was muted here. Okay, so you should be able to hear me, hopefully enough. So hello, my name is Martin Štefanko. I work in, not Quarkus team, but I work mostly on Quarkus at Red Hat. You can find me on these links, and please do if you will have any questions about Quarkus after the talk. Usually I am responding on all of these channels, so please reach out if you will have any questions. I want to point out this at the bottom. There is a code for 35% off of any Manning products because I am writing a book which is called Quarkus in Action, which you can already find in the early access program, first 6 chapters which are published. So hopefully I know a thing or two about Quarkus, so hopefully you will enjoy this talk. Please, I really don't have any slides. This is the closest to slides what you will see today. I will open the terminal and I will start typing. So please, if you have any questions to what I'm doing, just shout. If you want to see something, just shout. We are here to make it interactive, to give you the most of it as I can. So, and with that, I will show you this slide at the end, so if you would like to see some things. So hopefully, tell me when this is big enough. Everyone can see even in the back? Perfect. So, okay. So, the idea how to start with Quarkus. Of course, you probably know that there is Quarkus.io, which is a site where you can find all the information related to Quarkus. Sorry that I don't see you throughout the monitor. You need to deal with it. Basically, if you want to start with Quarkus, the easiest thing, if you prefer clicking start.coding or code.quarkus.io, maybe I should ask, how many Spring Boot developers or Spring developers? Raise your hand. Great. Start.spring.io, code.quarkus.io. Exactly the same thing. Just here you can see that in Spring Boot you have starters. In Quarkus we call that extensions. You can see that the list, you probably cannot see how big the bar is, but I can click here, show more extensions, and it's even smaller. I can show you it like this. It takes a while to scroll through these, even like on a computer. There is around, I think, 1,000 extensions which are supported. Quarkus itself contains a lot of these extensions directly integrated into the Quarkus platform. However, because the community demand is bigger than we at Red Hat can maintain in one single GitHub repository, we created a so-called Quarkiverse organization, which you can find on GitHub. GitHub Quarkiverse, if I can type it correctly. Yeah, Quarkiverse, which is basically another set of extensions which is basically done by community. Quarkus will give you a repository for your extension if you want to maintain your extension with the whole CI/CD integration into the Quarkus platform. So with every Quarkus release, you will be tested. You will still be sure that your extension compiles against Quarkus. However, it lives in your repository, which is under this Quarkiverse organization, and you maintain the code. So in this sense, if you have a very cool library, you can get it integrated into the Quarkus ecosystem and still maintain the integration yourself. And as you can see, there is also a bunch of these repositories done by community because we just cannot, like, I don't want to spend any more time compiling Quarkus if I need to work on my extension because of your stuff, more like this. But Quarkus comes also with this command line interface, which is basically just a CLI wrapping everything that you are doing in the command line with Quarkus. And one of these things is this create application. So if I want to create, because I don't like to click, create Quarkus application, I can just type create app.io xdefunc. Oh, no, let's call it DevConf 2023. Very sorry about that. So what this does is basically it will generate a Quarkus application with very basic stuff out of the box. Out of the box, we will get REST support, Maven wrapper or Maven config, basically some Docker files, And this is if you don't specify anything. With that create app, you can also specify any extension that you would like to add on the compilation to the project with -x. So I can start typing name of the extensions here, but I will not do this. The basic idea is that some of these extensions come with so-called code starts, which is basically some sample code to give you the idea of what you are basically integrating. But typically, this is very good for people that don't know what they are doing. Let's open this in IDEA. But if you know what you are doing, then typically it's just a stuff that you need to delete. So because out of the box, it added REST Easy Reactive extension. Why is this so slow? It, yeah, sorry about that. Give me a second. I need to remember the shortcut. I'm working on it. You just need to give me a time to remember the shortcut. So with this, we will get JAX-RS resource generated with some sample string. It's just some sample code to remind you of the API that you are integrated. What that Quarkus extension is actually only a Maven dependency from IO Quarkus, and this one, IO Quarkus group ID, and Quarkus dash name of the extension. Quarkus extension is basically integration layer of any library that you are putting into the Quarkus. Why would you want to use Quarkus extension and not directly the library? Because first thing, Quarkus is built around a few concepts which we don't have time to dive into in 30 minutes, so please catch me after the session if you are interested in this, which you have access to inside the extension API. For instance, build time / runtime processing of application code, compilation to native, so adding some custom flags to GraalVM, etc. So this is why if there is a Quarkus extension, please use that. Otherwise, in JVM mode, if you are running Quarkus on JVM, you can use anything that you like from Java ecosystem. In JVM, it's still same old, but brand shiny new Java application. If you want to compile to native, which is a separate use case with GraalVM, then you probably want to stick to extensions because that extensions will give you that guarantee that you will only type somewhere down here, -d or -p native, and it will compile to GraalVM native. Because that Quarkus extension is actually responsible to make this happen all the time. So if you have a custom library without that integration, it might cause some problems. However, you still have access to some APIs in Quarkus itself to mitigate this if you would need to. OK, so first things that always you will do with the Quarkus project, if you will open it, is so-called Quarkus dev. Just to mention, if you don't want to use this Quarkus CLI, in the background, all this does is call Maven Quarkus :den, which is Maven plugin, which is directly integrated here somewhere, Quarkus Maven plugin. However, if you use this Quarkus tool, the benefit that it gives you is that it will shield you from the actual build tool that you are using in the background. So you can also use Gradle, which is not that unpopular as many people think. So if I need to work sometimes on Maven and sometimes on Gradle, I am preferring to use Quarkus CLI because this will always run the correct invocation of command in the background. So what is Quarkus dev, or Quarkus is dev mode? So basically, this is single-handedly the most productive feature that I got when I started with Quarkus development. What it does is basically it runs continuously your application in the continuous process, and it dynamically recompiles any changes that you are making to your application. And if I am telling you any changes, big enough, let's just verify that I can call my application that generated hello endpoint that I got there. So now is my application responding from the greeting resource, hello from REST Easy Reactive. But we are on DevConf, oh, ahoy, the REST Easy Reactive. I will just save the file if I repeat the same call. That class was dynamically recompiled in the background. It was exchanged with some class loaders, etc. But in the general, you have a new version of your application in a few milliseconds, like in 800 milliseconds. So it's you can imagine that the workflow that you are doing is typically these terminals are on one monitor, IDE is on another one, and I am just continuously typing the code, just refreshing the page on one terminal, and my application is running for the whole day. Typically, really, if you are not doing something crazy, which, again, I'm working on Quarkus, so I need to do crazy, so I need to restart it a few times, but if you are writing your application, you don't need to stop this for the whole day. And basically, this is that first really nice feature. So where to go from here? Really, in 30 minutes, I don't have that much time to show you. So here in the bottom, you see that you can press a few buttons inside this terminal and something happens. So H will give me all the options that I can do inside this dev mode terminal. Now, probably second best feature that you will get in Quarkus is continuous testing. Since we are already recompiling your application, why we cannot run all the tests directly with it? So if I type error now inside my application, Quarkus will start continuous testing, and then it will start running my test in the background. And of course, it failed because I changed something which that test is trying to assert. It is expecting help from REST easy, and I now have always REST easy. So if I go into the test itself, and actually, let me do it like this. I will move this terminal into the same workspace, so you will see some magic. So inside that test, I will fix the test, and I will just save the file, and you will see that dev mode automatically recognizes that I saved the test, and it will rerun it, and we see that now my test is passing. Nice. For me, this was impressive when I saw this first time. So you get the idea that you are basically just typing your stuff, and you have this continuous testing enabled, and by just saving the file, all your tests are automatically rerun in the background. So if I don't see on the periphery that something red is jumping inside the terminal, I'm not even looking at it. I'm just typing continuously. One hack that I learned myself is actually because if you are familiar with Spring Boot test annotation, this will still run a new instance of Quarkus. Quarkus test will run a new instance of Quarkus against your test. But with the dev mode, this is still a runnable application which you can call normally. So if I'm not doing something which is really changing something inside the application which would interfere with what I'm doing inside my application in the dev mode, I will just comment out this Quarkus test application, and I'm pinging really the application in the dev mode, because you see that this took like 300 milliseconds if I need to rerun the test. But I think that with R, I can rerun it. And now you see that it only takes 18 milliseconds because this is just HTTP invocation against the dev mode. So with in a few milliseconds, I can run hundreds of tests against the dev mode if I'm just testing something which is not changing something, or if it's changing it in a way that I can still continue what I'm working on. But of course, then you will just uncomment the annotation, and it will start the new instance against which you are testing. Okay, it takes 300 milliseconds, which can bump up depending on the test, but you get the idea. So I put it back here, and press H again. And what is now happening? Yeah, better, sorry. So what else you can do? With that continuous testings, because definitely there will come a question like, I have a bunch of tests and this takes time. You can play with this. You can only set to run the fail test. You can, I don't know. Okay. Quarkus will try to do its best to guess what kind of code you are changing, and it will try to not rerun all the tests all the time. It will try to rerun only the set of tests which are relevant to the code which you are changing actually on that iteration of dev mode. But of course, this is still software, so it's a guess. But typically, it works pretty good. Or you can just toggle that broken only mode, which will only rerun tests that failed. So go ahead.
Is it just running unit tests, or are you integration that's being run?
So,
for example, I can have like Quarkus test resource annotation, and I can be stuck in like some of the dev services, for example, and then type Kubernetes stuff.
We'll get there, but yeah. So the question is if this is only running unit tests or it can run integration tests too. Actually, this is integration test because with that Quarkus test annotation, we are running a new instance. So yes, this will also run dev services and we will get to it. So this will run everything in the background continuously. Okay, I don't want to jump, so we will get to dev services definitely. Another cool feature that you can play with here is this dev UI, which by pressing D inside this terminal, you see that maybe you don't, but in the bottom, my browser opened a new tab, which is basically, oops, I didn't want to click, I want to put it down. It's basically a development clickable interface inside your dev mode where each extension can add whatever they want. So Arc, for instance, which is our CDI container, which is responsible for dependency injection, you can just click to list all the beans inside your application, like my greeting resource, for instance. Or you can see these very nice removed beans or removed components, because as I mentioned, Quarkus is doing a lot of stuff at build time. Of course, in dev mode, build time and runtime is the same thing because we are already building the application at the same time. But if I would Maven clean package, so I would actually compile my application, Quarkus would remove 65 CDI beans, which are never going to be used inside the final produced jar, in a final produce application. So this is like 65% less, 65 classes less memory and less processing at runtime, just to give you the idea. Oh, okay, extensions itself. We will get to it. Okay, so I am here in the right side terminal. I am in the same directory. So here I can run again that Quarkus ext, which is short for extension, which will print all the extensions that I have currently installed in my application, which is not totally true. Let me restart Quarkus here so you don't think that I am telling you something wrong, because you can see here that I have that CDI, small right context propagation vertex, which are some extensions which are always included in Quarkus because CDI, for instance, that Arc is integral component for Quarkus itself. Quarkus internals are wired through that Arc container too. Vertex, for instance, is a reactive set of libraries which is basically the core of Quarkus. Everything in Quarkus is reactive, and we will get to it. So this is why we have only REST Easy Reactive, because this is the only optional one which we added on top of that when we generated the default application. If you type -i here, which is installable, it will list you all the possible extensions which you can add to that Quarkus application, which is a very long list because we have only one extension. You can play with it, but we don't have time. There are categories. You can search for particular keywords, etc., inside the terminal itself. Or if you are lost, you can search inside that code.quarkus.io, or what I actually prefer, because, sorry, I need to go on quarkus.io, because typically, if I don't know what I'm looking for, I need to find the documentation on how to use it. So for instance, when I was trying to learn cache, I can just search in learn documentation, which is basically official Quarkus documentation that consists of set of guides, which are step-by-step instructions ranging from typically 15 to 30 minutes, but some of them are even 60 minutes, on a particular extension, how to add it to your project, how you can configure it, how to use it. So after that 15 minutes, typically, if I go into data cache, after these 15 minutes, I have the idea how to add it to my project, how to use it inside my project somewhere, blah, 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 somewhere. You get the idea. I personally, yeah, here, cache result. I personally really like this kind of documentation because in an interactive way, you will really create an application in which you can continue experimenting after you are finished with this guide. So typically, for me, if I don't know what I'm looking for, I am going to that Quarkus guides. But you have the idea. So if I want to add an extension, you have directly a command here, or you can just add it to your application. But since we are using the command line, I can use it here. So I will add, for instance, the one that I am maintaining, which is small right health. And I want to show you a magic. You see that just by adding an extension, Quarkus also restarted, and now I have new extension installed in my application. And actually, this extension comes also with some API/Q/health. So now I have exposed a new API. If I remove that, or before I remove it, I will show you what actually that Quarkus extension add is doing. It will basically just add the new Quarkus -smallRye health dependency into my POM XML. But this is enough to restart the dev mode, and you have that extension installed. So again, not stopping the dev mode, continuously running. I'm just experimenting, adding stuff. I can remove it, and hopefully this will just remove it. And after the dev mode starts, now I don't have that endpoint anymore because I removed the extension which was adding it. The funny part is that, let's take that cache one because I don't remember any extension. I will just copy-paste, or maybe I will just copy-paste this because I don't have that cache in the latest version, I think, locally on my computer. So yes, you see that even I don't have it on my computer, and what Quarkus does, it will dynamically downloads it from Maven, and it still works. So not stopping this really for the duration of what you are doing. OK, so let's remove this. Some more fun stuff. One of the very good features of Quarkus, after this what I was showing to you, is a framework for Hibernate ORM for database access, which is actually called Hibernate Panache, which is a framework done by Hibernate team, which is not in JPA, but it's something which is the preferred way how to do database access in Quarkus. And with this Panache, you have basically two options how to implement the entities, active record pattern and repository pattern. So if you are coming from Spring, you can do very similar repositories in Quarkus. But what I want to do is, because I can just add that dependencies directly into my POM and just save that file, and Quarkus will still restart in the background, I want to show you that what I basically added is just that Hibernate ORM, and I added a driver for Postgres. Just because, and this feature that I'm going to explain now is called dev services, just because Quarkus sees that I added a driver for Postgres, so I probably want to connect my application to Postgres, but I didn't configure any connection to Postgres, Quarkus goes ahead and starts a new dev services container for Postgres for me. And this actually started a Postgres container in the background. And if I press C here, you will see that it started a new Inspiring Gagarin container for me, and it automatically injected configuration that automatically connects to that container. So now my dev mode application is actually connected to a real Postgres database running in the container, which is tied into the run of the dev mode. If I kill now the dev mode, it will stop the database in the background. And this feature, dev services, it's something, and now you can start typing basically any code, Avenger, extends, Panache, and maybe I need to reload Maven. Come on, oh, come on, Panache, entity. This needs to be entity. This is what I'm typing here is that active record pattern. So basically, we are encapsulating all database operation into the entity class itself. So I can just type my properties in a public field because I can. So string name, public string civil name, and public boolean snapped. And this is everything that I need to do for my entity. ID is generated because this Panache entity contains the generation if I don't need to extend it. Of course, if you extend the Panache entity base, you can customize it, but you don't need to. What is happening? Go back. And because Quarkus is doing a lot of processing at build time, we actually can, not force you, but we can tell you to use public fields, because if you have private fields with public getters and setters, which are just getting and setting, it's just public field encapsulated. What Quarkus does at compile time, because it can also generate bytecode, it will first thing generate getters and setters for you in this class, and of course default constructor equals hash code, etc. So it's a valid entity, and it will rewrite dynamically any accesses to these public fields in different classes to use that newly generated setters, because you can dynamically transform bytecode. If I want to use it inside my entity, get v. Let's do it at path full, and this will be a list of, list of Avengers. What is happening now, computer? Get all, and we will not throw exception. Because everything is now encapsulated inside that entity itself, so select star from Avenger entity is just list all. Now you have a bunch of static methods directly on this resource, and you also have create, we will return Avenger, a bunch of, we will take an Avenger, if I can type Avenger. This is not auto-completed. Of course, we need to still handle transaction, but what I can do is just on the Avenger itself call some methods which will basically encapsulate the entity manager operation. So if I want to persist something, it's just Avenger.persist, and I can now return the Avenger. We don't need to play with this that much, but you can imagine that, like, for instance, that persist operation will actually do the persistence into the database, so you will get the ID generated, etc. I don't have that much time to show everything. So if I hopefully, and I need to move this because I want to have this on path slash, and we will move hello on path slash hello. So we will get, let's do Avenger. So if I now call 8080/Avenger, hopefully I should get a list of Avengers. Yes, I am getting a list of Avengers, which is nothing, but with Panache, all you can actually do inside the dev mode, create a file in service main resources called import SQL, and I hope that I have Avengers import. I have, where you can place any SQL that you want to get executed when the Panache is bootstrapping. So hopefully if now it restarts, yes, I am getting a bunch of Avengers, but I don't have the correct extension. And this is the one place that it sometimes breaks, so wish me luck, and it broke. So this is that one place that, because I am rewriting the extension which is encapsulated in the background, thanks, the REST Easy Reactive extension. REST Easy Reactive Jackson is just adding Jackson support on top of REST Easy Reactive. I need to restart the dev mode. But at least I can show you that because I killed the dev mode, it also killed my Postgres database. And now a new Postgres database is starting for me because I'm restarting the dev mode again. And now I have a new Postgres for the new run of the database. And this time, hopefully, I am getting back Avengers in JSON. Okay, so this is basically the dev services is automatic management of test containers in the background. So basically this works out of the box. And because I don't need to remember this, I can just type here dev services. This works out of the box for a bunch of stuff. Of course, we are adding this continuously. So it works for all the databases like Postgres, MySQL, I don't know what else is supported in the container itself, MongoDB, as you can see here, but it also works for Keycloak, for instance. If you are working with like OEDC, for instance, it will automatically start Keycloak for you for dev mode. For IMQ or Kafka, it will start Red Panda broker in the background. So it's very streamlined development where you don't need to care about the infrastructure that is basically you are depending on. It's automatically managed in the background for you. And these dev services are not only limited to dev mode, but also if you write any test that would need to access the database, actually that Quarkus test will start a new Postgres container just for that test execution. So every time that you are running tests, if I would run continuous testing where I would be persisting something to a database, it would run another Postgres database, which is just used for the testing. So no more like application development against Postgres or MySQL and testing with H2. Now you are testing with real database. Go ahead.
So if you want to run the test, it will create a second one?
Yeah, it would start a new Postgres just for that test execution. Okay. So one last thing, because we don't have that much time, but if you are interested, I have a computer. We can sit somewhere after the talk, and I can show you all the stuff. One other stuff that I like personally is this REST data extension. Thank you. This is exactly what I can do in 5 minutes. So this is basically extension which is generating REST resources based on your entities, which is, as I learned, 95% of application development in Java is CRUD over database. So what I can pick here is basically, because I already have JDBC and REST Easy Reactive JSON, I can just copy paste this ORM REST data panache extension and paste it into my application somewhere, if I can find. Save this, and all I can do now, because I always forgot this when I'm talking, so I will just copy paste entity panache entity resource. Okay. I can just create an interface, call it Avenger resource, and this will be interface that extends panache entity resource of my entity and of my type of my ID. Again, I need to give idea and hint that I have a new extension. And that's it. I think that's it. So, still nothing? Okay, now you work. I will on purpose remove this Avenger here, and I will remove this here. So we no longer have, okay, at least I can show you that. If I save the file when it's still not compiling, dev mode will not crash. It will just print you the error and give you an opportunity to fix it. So what did I miss? Oh, this looks good. Good? No. Avenger resource Java. Oh, I have, what am I missing? No, it shouldn't have needs for path. No, this one. This is like Java. Cannot find symbol. Maybe you need, oh, I know what is happening. This will probably not work because I don't have that extension downloaded, because this is kind of on purpose that Quarkus will always do release like 1 day before I have this talk. And I will run into these kind of issues. So we will give it a second, but basically what this does is basically it will create that CRUD operation REST resort over our entity that I will pass there out of the box. So now I should still have that Avenger, but now it's coming from the generated resource, and you don't need to trust me because, oh, not this one, small I open API. I will just add a new extension, which I also don't have probably downloaded. Come on. My computer is somehow slow today. Sorry about that. Come on. Okay, any questions until my phone internet will go? Go ahead.
When you're using Panache, how do you handle database migrations?
There is a separate extension for several extensions, actually, for database migration. We can talk about that later. Now it's taking a little bit of more time because it needs to restart the database if I'm adding a new extension, because it's broader. Even I'm out of time. Okay, so thank you. I will just show the last thing. Just so you trust me. Small Ray Open API, come on. Where are you? Where is Open API? Oh, come on, I cannot find it. Oh, okay, I cannot see it here. Is it there? Okay, let me do it once more. Okay, I don't know what is happening, so I will show it after the talk because we are out of time. But basically, you need to... Wait a second. Give me 2 minutes. You need to believe me that it basically generated a new JAX-RS resource with all CRUD operations over the database, especially as exactly the same way I was doing in that greeting resource, just this is doing it out of the box. So basically that CRUD over the database is 2 classes because I don't need a greeting resource. So now it's over. Thank you for your attention.
Can you hear us? Perfect.
You shouldn't hear yourself.
So you have the first one?
Yeah. Okay. Hi, everyone. Thank you for attending this talk that will be about securing Python project supply chain. So a few words about ourselves. My name is Maya. I'm a software engineer at Red Hat in the Emerging Technology Security team.
And hi, my name is Fridolin. I used to work at Red Hat. I used to work at Datadog. I'm an entrepreneur now. And you can find more information about us on Twitter, Mastodon, or GitHub.
Okay, so let us start this talk with a simple question, which is why protecting your supply chain actually matters. So if you follow open source security or maybe Python news, you might have seen this information pass, which is that not too long ago, PyPI maintainers decided to temporarily deactivate new user registration on the index, and also the upload of new packages, of new projects, because they got overwhelmed with the volume of malicious packages that got uploaded on PyPI. So they couldn't handle it, everything. It was very overwhelming for them. So they had to suspend all those uploads. And maybe a little more, less recently, in January, you might have seen that PyTorch, the famous machine learning library, was compromised. Some nightly bit of PyTorch was the victim of a dependency confusion attack. So we'll see what a dependency confusion attack is later in this talk. But this is also a supply chain attack. And this is not a coincidence if you have seen all those articles passed recently, because a study showed that year to year, for the past 3 years, supply chain attacks have increased by more than 700%, which is a very high growth rate. Supply chain attacks can cause a lot of damage to an organization or a project, can be both financial and also reputational. And if you have a weak supply chain, this can get you into a lot of legal and compliance issues as well. So some new regulations were put into place to try to secure software supply chains, and one of the most famous ones was issued in 2021 by President Biden. And this was the Executive Order 1421. It was called Improving the Nation's Cybersecurity, and it was issued after the pretty infamous SolarWinds attack, which affected a lot of big organizations and some branches of the United States federal government. And this executive order basically tells corporations that collaborate with the US government that they should be more strict about supply chain standards they adopt. So for example, it pushes organizations to adopt secure authentication to servers, or maybe like stricter protocols and this kind of things if they want to sell software to the government. And this includes things like software bills of materials that we'll cover later, which are basically like a list of the ingredients that compose your software.
Okay, so now let's take a look at supply chain threats and vulnerabilities. Maya already mentioned infamous SolarWinds attack. It was an attack on SolarWinds Orion platform that is quite well used. It's a network performance monitoring platform. And what was done here, attackers basically uploaded a malicious DLL file that was subsequently pulled by a build system, which produced software artifacts that were consumed by customers. These software artifacts were properly signed, so customers were not aware that there was some malicious behavior. And the effect of this attack was quite large. So more than 18,000 customers were affected, and more than 400 of US Fortune 500 companies were affected by this attack. You can see, for example, the White House or Pentagon or State Department or National Security Agency that was affected by this attack. What happened? SolarWinds stock price went down. That's not the worst thing, but attackers were able to access confidential information of customers. What could SolarWinds do better? They could follow SALSA framework. SALSA framework is quite recent. Quite recently, it went to version 1. SALSA stands for Supply Chain Levels for Software Artifacts, so it's not a sauce, it's not a dance. And SALSA defines 4 levels, starting from level 1, where there are basically no requirements on the build platform, up to level 3, which is like properly hardened build platform. SALSA introduces this image. So you can see there's a producer that produces source code, and the source code is stored in a source repository. Then build platform pulls sources, pulls dependencies, and creates a package or the resulting artifact that is subsequently consumed by consumers. SALSA defines threats in each step, so what can go wrong, but also defines how to prevent from these threats. So how to, for example, prevent from submitting unauthorized code or make sure that the source repository is not compromised. Now let's take a look at some toolbox to protect your Python projects. So the very first toolbox thing we will talk about is TAF. It's the update framework. It's called TAF because it solves TAF problem, and that is basically securing updates and preventing temporal attacks, rollback attacks, or key compromise attacks. The reference implementation is based on Tandy. That's an updater that was used in Tor. TAF is, let's say, more generic, but borrows many ideas from Tandy. There's also Uptain, that is a similar project to TAF that is used in automotive industry. It's used by companies that populate updates to cars. The reference implementation of TAF is in Python. You can find it under Python TAF. And one company, Datadog, used TAF to secure agent integrations, that's software that is shipped to customers, and uses TAF and InToto, that we will talk about later, to securely ship software to customers. There were also efforts like PEP 458 and PEP 480, PEP meaning Python Enhanced Proposals, to secure PyPI itself, and we will talk also about it. TAF is also used in Zigstore to securely download public keys for instances of Zigstore. I already mentioned InToto. So InToto is a framework to secure supply chain. What it does, it basically defines what each step in a pipeline should do. So if a pipeline should, for example, write something or package something, then there is created attestation, so you are sure that each step in a pipeline performed desired task and is properly signed. So users who consume resulting artifacts can verify that each step in the pipeline, each step in the chain did its job properly. Now.
Okay, so now let's go to an important part of every supply chain, which is code signing. And for this part, I would like to introduce a quite new project when it comes to the space of code signing, which is Zigstore. So Zigstore was started a few years ago by different institutions and companies like Google, Red Hat, and Purdue University to make software signing more accessible and simpler. So it provides a very secure and simple interface to sign any kind of codes and containers as well. And to use it, you don't need any specific cryptography knowledge, which is kind of an improvement if you compare it to other signing standards like PGP, where sometimes the configuration can be a bit complex and you might need to know about the underlying cryptographic protocols that the tool uses to sign your software, which is not the case here. So one nice feature of Zigstore is that it uses OpenID connects to sign software instead of self-managed private keys. So OpenID Connect is an authentication protocol. And what it allows you to do is to bind your email address or any kind of identity, like, for example, GitHub workflow run, to your signature. So instead of having a permanent public key bind to it, you can have something more identifiable for your end users, like your email address, and more personal. Sigstore has a client implementation in Python. It's called Sigstore Python, and you can check it on GitHub. So it's a pretty good tool. It has a lot of integrations, like, for example, with GitHub CI runs. You can use it as a GitHub action. You can use it as well as a CLI. And I put an example on this slide of what it looks like to sign with Sigstore Python. So it's very simple, as you can see. If you want to sign a package, let's say a Python package in this case, the only thing you need to do is enter Sigstore sign, your package, and then it will redirect you to an OIDC session. So basically, this is a web browser page that opens up. And you need to enter your credentials to an identity provider, which is, for example, Google or GitHub, which are currently supported. Enter your password to authenticate, and then it will validate your identity and bind it to the signature of your artifact. Here's the package. So you sign your artifacts, and the second step is for your end users to verify the signature. So here again, it's quite simple. This is the second command. You just need to run Sigstore verify here identity, and you need to pass the email address of the signer, which can be found on the signing certificate, which is provided by Sigstore. And you need to pass as well the URL of the OIDC provider. So here, for example, the signer identified with GitHub accounts, so you will need to pass the corresponding URL. And just what we call a bundle file, which basically is some kind of verification file that contains all the materials you need to verify a signature with Sigstore. Okay, so before we skip to the next part, I would like to make a quick reminder about the difference between what is malicious and vulnerable. So a vulnerability in software is some kind of flaw in a computer system that can weaken the overall security of the system. But the thing with vulnerabilities is that they can be exploited, but they are not always exploitable. And actually, some study found that less than 10% of vulnerability are actually exploitable, and less than 1% of them are actually exploited. On the other hand, malicious software or malware is any kind of software that is intentionally designed to cause disruption in your system. So that includes, for instance, ransomware or Trojan horses or viruses, for instance. So to find out about vulnerabilities that exist in software libraries, for instance, you can use vulnerability databases. So here we chose two examples. The first one is OSV. It's a distributed vulnerability database for open source projects. And what it does is that it aggregates vulnerability databases from different ecosystems like Golang, Rust, or of course Python with PyPI data. And it makes them available in a format called the OpenSSF vulnerability format. The second example we picked is GWAC. So that stands for Graph for Understanding Artifact Composition. And GWAC is a graph database that aggregates all kind of software metadata about security, like, for instance, artifacts, identities, attestations like SBOMs we'll talk about later, and it stores the relationships between those artifacts and metadata inside the edges of the graph database. So GWAC is quite useful if you want to prevent supply chain attacks because it allows you to understand better the relationship between the different components in your software and, and how they are used together, for instance.
If you try to apply this to the Python ecosystem, there is no direct support for vulnerabilities in pip, the Python package installer. Nevertheless, there is a tool called pip audit. It uses the OSV database that Maya mentioned. And what it does, it audits already installed Python environments. So you can issue pip audit, and it will show you vulnerabilities, but also packages that introduce these vulnerabilities to your environments. There was also an experiment called pip cuddle. It basically resolves application dependencies without vulnerabilities or only with vulnerabilities that are acceptable ones. So it accepts a configuration file. In this file, you state which vulnerabilities you are fine to have in your application, and then pipcuddle resolves application dependencies, and then you can install all the dependencies, including transitive ones. There's also a project called Security Constraints. What it does, it consumes security recommendations by GitHub. So you need to provide GitHub token, and it can generate constraints for your application. So the resolution process then checks these constraints and resolves application dependencies without vulnerabilities. The PyPI is quite let's say, bad when it comes to number of malicious packages published each day. So PyPI maintainers claim that there are roughly 40 malware packages introduced each day, and they need to be taken down manually. There's a dataset called malicious software packages dataset, and it aggregates packages that were published on PyPI but were taken down because they were malicious. So if you want to experiment with malicious code, you can do so, just be careful. There was also an effort, which is an open source tool called Guardog. It scans Python source code and tries to find patterns in the source code that can be malicious. Guardog uses SemGrep rules to statically analyze the source code and give you information whether the given package is malicious or not. Guardog is not used on PyPI, but you can use it on your own, or you can plug it into your system. Maya already mentioned SBOM. SBOM was mentioned also in the executive order issued by the US president. SBOM stands for Software Bill of Materials. What it does, it basically states all the software that was used to create or assemble some application. So in this listing, you can find all the dependencies, their version, and there are two formats that are used in the industry, CycloneDX or SPDX. There are more, but these are, let's say, the most used ones. If you have a software bill of material for your application, you can also use VEX, that stands for Vulnerability Exploitability Exchange. And VEX states whether the given vulnerability that is present in your application is actually exploitable. So if you have a vulnerability in your application, it doesn't mean that an attacker can exploit your application because, for example, that vulnerability doesn't need to be on call path, or the application configuration prevents from exploiting the given vulnerability, or you deploy your application into an environment in which that vulnerability is not exploitable. There were two efforts. One was OSVDev effort to, let's say, standardize VEX in the industry. They introduce a file that you can maintain in your Git repository, and that file states information about libraries that you have, information about vulnerability, and whether that the given vulnerability is maintainable or not. OSVDev also proposed a way how to, let's say, manage multiple VEX files across repositories, so you can check multiple files when you are consuming multiple libraries. There's also OpenVEX standard in the industry that was pushed by ChainGuard, the company, and it proposes a standard in the industry to describe VEX for your application. So here is an example. It basically states vulnerabilities and also their status and what introduced the given vulnerability. If you want to run your Python applications, you can use Python container images. So Red Hat produces some Python container images, UBI or Fedora-based source-to-I images. The main benefit of these images is that it's large RPM ecosystem with vetted and very well-maintained software. You can use micropip in these container images. And on the other hand, there's also ChainGuard's Python image. It's based on Wolfie. They maintain their own ecosystem. for packages, and it uses multi-stage builds. So you have one container image that is used for building your application, and then another one that is very minimal, just with Python runtime to actually run your application. They try to minimize number of CVEs present in the containerized environments.
Another thing you might want to do if you want to check for potential vulnerabilities in your source code is use static source code analysis. And we picked an example here of such a tool, which is called Bandit. Bandit was started by the OpenStack security team at Red Hat. And what it does is that it scans the files in your Python project. And then from these files, it generates ASTs, abstract syntax trees, and it uses plugins to analyze the risk for potential vulnerabilities, but you can choose which plugin you use. So for example, you can choose if you want to detect things like hard-coded passwords, shell injections, or crypto mining, for instance. Okay, so now let's go over some initiatives that the Python community has taken recently to secure the ecosystem supply chain. There are a bunch of them, but we chose a few important ones. So the first one is mandatory 2FA for maintainers of critical packages. So it is a list of packages that are widely used by the Python community and by developers. And so PyPI maintainers chose to give away for free with a sponsor security keys so that the maintainers of those critical packages can securely authenticate to PyPI and upload packages in a more secure way. And more recently, they announced that in 2023, so this year, 2FA will be mandatory for every package maintainer on PyPI. They also have another initiative, which is Trusted Publisher, quite recent as well. Trusted Publisher uses the OpenID Connect protocol again for users, maintainers of Python packages to use an OpenID Connect identity to get a temporary identity token, which allows them to get a temporary access key to PyPI instead of the normally the API key you would store permanently, for example, and use and reuse in CI workflows to publish packages, which is a bit more insecure. And one last measure is pretty recent. They chose to drop support for PGP signatures from PyPI. So a Python community member made an audit of how PGP signatures were generated and used in PyPI and found out that they weren't that useful and were actually quite hard to maintain, so they chose to just drop support for it. So now we'll go over more initiatives to come from the Python community.
Okay, so let's take a look at improvements. We will talk about PEPs. PEP stands for Python Enhanced Proposals. That's basically a way how to describe what you want to do in the Python ecosystem, and then the community decides whether it's good or not. The first one is PEP 458. That's about securing PyPI downloads with signed repository metadata. This one was accepted, and it uses stuff, the framework that we discussed before, and it basically secures downloads of Python distributions, so you can be sure that you are downloading the right software from PyPI if you're a PyPI consumer. It's still work in progress. Then there is PEP 480. That's about surviving a compromise of PyPI. So imagine someone compromised PyPI and uploads packages there, own packages. How do you want to check that? This PEP describes a way how to do it. It's based on PEP 458, and it adds developer keys to Warehouse or PyPI. Currently, it's in a draft state. Also, there might be a new PEP in few days, so stay tuned. Now let's talk about dependency confusion attack. So at the beginning of presentation, we described one dependency confusion that happened in the PyTorch ecosystem. So if you are a user and you install Flask and Torch, or PyTorch from two indices, let's say PyPI and PyTorch. You want to consume PyTorch from PyTorch because there are, let's say, special builds that you would like to use. In the Python ecosystem, these indices are treated as mirrors. So it doesn't really matter for pip or potentially other installers which index is used to consume a package. So in your example, you would like to install Flask and Torch and also transitive dependencies of these libraries, but which index should be used? So imagine that in this case, you are consuming Torch from the PyTorch index and a dependency of Torch called Torch Tritron also from the PyTorch index. But if you are an attacker and you upload a package to PyPI with the same name as the one on PyTorch index, then it can cause troubles because these indices are mirrors, right? So the Torch Tritron can be malicious and you can consume malicious package. If you would like to detect possible dependency confusion in your Python applications, you can use a tool that is called Yorkshire, so a cute name, right? Then there is another PEP for extending the repository API to mitigate dependency confusion attacks. That's basically the PEP that's addressing these dependency confusion attacks. It's still in draft state, but what it introduces a way how to create a contract between indices. So imagine PyPI says that project Torch Tritron is trusted on PyTorch, and PyTorch index says Torch Tritron is trusted on PyPI. So there is a contract between these indices, and consumers or installers of packages can verify that these packages are or trust each other, so they can pull from PyPI or PyTorch. If there is no this tracks information, then the installer can fail and notify about possible dependency confusion. Another PEP called recording the provenance of installed packages, that's PEP 710. It's based on PEP 610, recording the direct URL of installed distributions. So if you install a Python application and you install it using a URL, so let's say you use GitHub to download an archive of pip, then pip and other installers create a special file called direct URL.json in a metadata directory called distinfo, and track information that you installed pip from GitHub. And this is the URL, this is the hash of file. Nevertheless, there was no way how to find out what you actually installed if you issued just pip install pip or Flask or whatever application or whatever library. So PEP 710 introduces a new file called provenance URL.json that states what file was downloaded, what were the hashes, when you installed packages using their name, and optionally their version. It also tracks information about indices. It's still in draft state, but if you are interested in it, feel free to check it. And now we will have an opportunity to win something. So for those who were listening to us, there can be something good. So the rules are, we will ask a question. I will try to check who raises hand the first, and then we will give something. Does it sound okay? Yes? Okay, let's do it. So the first question, to which project mentioned in this presentation does this photo relate to? Yeah. Sorry. Salsa. Yes. So we have a winner. And
you can come claim your prize if you want.
So that's right. You have like mild salsa dip together with matches. Okay, so another. To which project mentioned in this presentation does this photo relate to?
Yes.
Yes. Can you guess also the prize? We We actually borrowed this idea from Guac people, so developers behind Guac. Yes, so Guac, Graph for Understanding Artifact Composition. Okay, to which project mentioned in this presentation does this photo relate to? Anyone? Yes. Wait. Okay, so the prize is, yes, so salsa is the correct answer. And you get a ticket to salsa lessons, so you can choose between Maya or me. Okay, there's also plan B, so.
Okay, you get hot salsa.
Yes. So, hot salsa it is. Okay, to which project mentioned in this presentation? Yes, we have? Yes, it's Yorkshire.
It's not a dog, sorry, but...
So, it could be also guard dog. So, what do you want? It's a lollipop. Okay, and now the tough one. To which project mentioned in this presentation does this photo relate to?
It's a very hard one, so feel free to propose any. No. Yes? No. No, that's not it. Okay, a hint? Yes. Okay. You win chocolate.
You win chocolate. We wanted to ask for signatures of Zig Store guys, but maybe next time. Stickers. Oh, that's a good idea.
We didn't have any Zig Store swag, so yeah, maybe next time as well.
And I think we have some space for questions, so if you have any questions, feel free to ask. Yes?
You mentioned that there will be a new PEP in any day. Why are you so sure about that?
So I'll repeat the question. So I mentioned that there probably be some PEP, like new PEP. So I collaborated with one PyPI maintainer, that's Donald Staft, and there is something written, so let's see if it will be public or not. There are also other engineers involved, so for example, Trishang, who is behind TAF, and other people, so let's see if it go public. Yes?
When you mentioned that they were removing GPG from PyPI, you kind of implied that there was something actually harmful about it up there. What were the reasons?
Okay, so I think if you want a complete answer, William Woodruff published an article about it, which is pretty explicit, and he gives details about the whole audit he did on PyPI about GPG signatures. I think it's called something like GPG signatures worse than useless. So that's pretty explicit as well. So I encourage you to check it if you want a really complete answer on why GPG signatures were not worth maintaining anymore. Yes? Oh, yeah, sorry. I just repeat the question for... so the question was, why exactly are GPG signatures not considered worth maintaining anymore by PyPI? Sorry. Yes? Okay, so the question was, if I understood, if we consider ChatGPT as a tool to prevent malware, right? And that there is a tool called Package Hunter that can help detect vulnerabilities. Is that correct?
Or yeah, Package Hunter or similar, runtime, let's say, by executing the
Okay.
dependencies and seeing
Runtime vulnerabilities. Okay. I have not considered ChatGPT personally as a tool. For this talk, at least we didn't provide any example. I'm sure some tools use it now, but honestly, I didn't search into it. I don't know if you did. Okay. No, we haven't considered it yet.
We are out of time.
Okay. Thank you.
So, thank you.
perfect. My talk won't last that long anyway, so that's fine.
Everybody does this.
Yeah, but I done this talk a couple of times.
Okay.
Krabičica. What is krabičica? Box. Ah, that's very nice. Yeah. Yeah. Wait. I can do it. I just didn't notice. Yeah.
Can you?
Yeah, I can. Look.
Okay, great.
And 5 minutes as well. Yeah, your colleague told it. No worries. Just need some water. You give me the go? Thanks. Hi, everybody. Thanks to be here for this talk about chopping the monolith. I'm Nicola Frankel. Well, nobody cares anyway. Just to be on the safe side, I do this talk in multiple countries. In some countries, it can be considered offensive to contradict the attendees. I'm sure here it's not the case, but if at any point you feel offended by my opinions that contradict your core beliefs, just leave at the moment, and don't hold it against me. So that being said, we live in interesting times where if you are doing microservices, by default, you are a good developer. And if you are working on a monolith, you are a bad developer. Who here is a good developer? Good. So you are doing microservices, right? I know, hey, come on. That's the assumption. Who here is doing microservices? Come on, raise your hand. I want to see everything. Okay, half the room. That's an interesting take. So we live in an industry where we are supposed to be engineers, but we mostly live by hype. Microservices, good. Monolith, bad. You might see that I have a bit of gray hair, which means that I'm probably like either old or experienced or both. I would like to think that I'm experienced. And just I want in this talk to perhaps challenge some of those beliefs and offer some ways that you can do otherwise. So just to get back on the initial microservices stuff, I won't read it to you, but basically, this is the definition of microservices by Martin Fowler. So if you have anything against this definition, you bring it to Martin, not to me. That's not my problem. This I consider the truth. If you are not happy, well, go back to him. Again, in the same article, he describes several characteristics of microservices, right? And in general, here, hey, cool, right? You know, once I did this presentation internally, no, not this presentation, but a presentation, and I thought that was a very cool demo, and when I did this stuff, everybody said, oh, I thought that was my demo. Not at all. They didn't care about the demo. They care about the stuff. This is $100. Anybody can buy it, huh? Anyway, so the microservices stuff, well, componentization via services, everybody does it. That's basically the definition. Organized around business capabilities, blah, 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 blah. Products, not projects. Among the people who are doing microservices, or said they were doing microservices, who is organized around products, which means you have a start date, and you have a recurring budget over the years. You have no end date to the project, at least at the beginning. At some point, it might stop. Whereas a project has a start date and an end date, and a budget over the project, and probably over budget after some time, but that's normal. So who here is organized around products? Okay, like 10 hands at most. Yeah, because you have 2 hands. Good. And so you see that people who were saying they were doing microservices, according to this physician, they are not really doing microservices. They pretend they are doing microservices because they have some of the characteristics, but not all of them. Now, if we get even further, I remember when this microservices trend started, like everybody was talking about Conway's law. The people who advertised for microservices said, you must revert Conway's law. Who is not familiar with Conway's law? Okay, so the idea is in the thesis by Melvin Conway that your architecture mimics the communication channels of your company, of your organization. That's his thesis. And yeah, I was happy to meet him. Come on, I need to brag a bit. And so, because we are organized like this, so we have front-end engineers, we have middleware engineers, and we have database administrators, then we have a layer architecture. So if we want to do microservices, we need to use Conway's law. So if we want this architecture, we need to have self-contained autonomous teams. So I will ask the question again, and I have nothing against you. Who here is organized, and who is doing microservices is organized like the diagram on the right? Not the, half-half. In general, it doesn't go in your direction if it's half-half. But anyway, okay, still 10 hands, but not the same that, who were organized around products, which is interesting. And the poster child for this organization is Amazon Web Services. Now, they popularized the idea of two pizzas team. Well, the side of the pizza depends on which country. If I belong to the team, that's different. But basically, they are like small, self-contained, autonomous teams. So the idea is you want to go from the organization on the left, which is probably your legacy organization, to the organization on the right. And for that, you need this person. So now the question is, who is this person? Who I want to illustrate with this picture? Who? Banana Man, yeah, you are a second person who tell me that. I don't think you have many banana men in your organization at the moment. So that's the wrong answer, but that's a funny one anyway. Monkeys. Monkeys. Yes. Okay, you are now responsible for the real answer, which is middle managers. Is there any monkey in the room who belongs to the definition? And now everybody is super afraid, right? On a more serious note, yes, if you want to move your organization into a certain direction, you need the help of middle managers. Of course, you need to have the willing and the backing of the executives, but nothing will happen if you don't have like the help of the middle managers. Never works. And now comes like the $1,000 question. At the head in this group is a middle manager. In this group as well. In this group as well. Where are the middle managers here? They become engineers, I'm not sure. Another answer would be pitchy. But actually, is that the problem? You want the help of people to help you make themselves completely useless. Because even if on the organization on the right, you might need some middle managers, I mean, the basic idea of autonomous, self-contained team is there is no manager. And if I might add, You might think that, again, something against the managers. I have something against the bad managers. And bad managers' main tasks is to accept my vacation requests, to be the proxy of my raise every year when I have one. And when I mean the proxy is you cannot negotiate, right? It's just, hey, you've got X%. Yeah, thank you. Or, oh, I'm super unhappy. But whatever happens, it's just a proxy. And do some reporting. This is what bad managers do. I have a couple of good managers who helped me achieve my job. They were really supportive, but like in 20 years, 5, perhaps 4. So that's the problem. So I believe that it's very, very hard if you have a legacy organization to do microservices. What you might achieve is you will have technical microservices and still your regular organization, which means you will have none of the benefits of microservices and all of the problems. Congrats. Now, how does it work in real life? Well, you have one senior architect, someone who is very technical. He reads about microservices in a magazine. He says, wow, that looks cool. We can solve all our problems. He has some influence in the organization, talks to the chief executive officer, talks to the other executives. He got buy-in. You go full microservices. As I mentioned, you've got none of the benefits. Then he quits. Who is going to maintain the microservices architecture? You. Because you call them monkeys, right? So the people who are left need to maintain that pile of crap. But at least the guy has, or the woman, because, I mean, everybody needs to be represented, has microservices on their resume. Full win for them, full loss for you. But the question is, why are we so obsessed with microservices? I mean, there must be a reason somehow. So in another article, Fowler lists 3 main benefits of microservices architecture. The first is strong module boundaries. The second is technology diversity. And the third is independent deployment. So let's see if any of them is reason enough to move to microservices. First one, strong module boundaries. Yes, you have completely separate repositories, unless you have a monorepo, and then I never understood why you can have microservices and monorepo, but let's forget about that problem. So you don't have related code base. Of course, you have no dependencies between them. This is strong module boundaries, right? Yes, this is, however, a small benefit for a huge, huge investment. There are other ways to get strong module boundaries. For example, if you are in the JVM, you can have your modules, your like GPMS modules. You can have like static checks with Sonar that says that this package cannot call this package. There are other ways to achieve that. This is not reason enough. It's like saying, oh, I want to learn with my left hand, so I will cut my right hand. It will work, sure, but I'm not sure it's the only way, and it has a strong side effect. Technology diversity. Everybody loves diversity. We are in IT, we must be diverse. And so technology diversity is saying, hey, we are a Java shop, but I love Rust. What? I love Rust. I also love Kotlin, but Rust is a better example. So I love Rust, I want to learn Rust, and though we are a Java company, my next microservice will be in Rust. And it's good because it's diverse, right? And now I leave the company, yeah, you are still the one going to maintain the Rust shit that I created, right? Thanks to be seated on the first row. I have stickers for you afterwards for your pain. I really appreciate that. So diversity is the good thing, but the idea of technology diversity being a benefit for the company is complete crap. I mean, even if you are the Java shop, it's very hard to recruit a good Java developer. Imagine recruiting a Rust developer if you have no clue about Rust. No great idea. So the only thing that I have is independent deployment. So this is like a project, and you have like 3 main phases: specification, implementation, and deployment. So this is outside our scope, the specification. Mainly it's communication between the business and us. It's incompressible. However, what we can work on is implementation and deployment, and this is like known as the lead time. So the idea of deploying often is not a new problem. We already had this problem before. But before, we did it in a very different way. Before, we had release trains. So we deployed, let's say, 4 times in the year. It's not funny. You're probably using right now software that we deployed like this. And the idea is that it's very hard to test the whole monolith. So we cannot test it completely all the time. So we need to reduce the number of deployments, again, to X time, let's say 4 times a year. The thing is, the business needs to wait 3 months to get their feature. But who here is a developer? Yeah, nearly everybody. We are always late, right? Come on. We are always late. So if you miss the train, they need to wait 3 months extra. Business is never happy to wait 3 more months. So what do? Well, we cannot deploy. But there is a trick. You can still deploy if it's a bug fix. It's not a problem. You just ship the unfinished feature, and of course, now there is a bug, and you can continue working on the feature. Yeah, it rings a bell, right? I know. I mean, if you have a stupid rule, then we are creative people. We find a way to go around the rule. But this is based on an assumption that it's not possible to test the monolith well if you release often. And the assumption that the microservices people tell is that they never tell it. They tell it's not possible to test the monolith well. The underlying assumption is that it's, of course, very easy to test the microservice well, meaning that the microservices is completely self-contained, has no dependency to others, there will be no side effect, whatever. Of course, there will be less ripple effects, unless you have a mono repo, blah, blah, blah. But still, the assumption is completely crap. You have hard contracts, yes, but I'm pretty sure that there is some implementation detail that leaked. And then you can break something if you just test the microservice. So, in my opinion, the real problem is we think of the monolith as a monolith. However, if you have worked for some months or even some years on a code base, you may have noticed that some parts change very frequently or very randomly, and some other parts are very stable and very rarely change. Do you also have the same experience, or am I the only one? Yeah, okay. And so my experience is that, in general, it's the business requirements that makes the change, or a change in law. So business requirement, frequent, low, random. We already had this problem at the time when I was young and a young engineer eager to develop my stuff. How did we handle it? We used the rules engine. Who knows about rules engine? Oh, not that many people. Who doesn't know about rules engine? Okay, and then some people are Schrodinger's cat. They are between knowing and not knowing. Okay, that's interesting. Okay, okay. So for those who don't know, the idea of a rules engine was you would deploy once the engine, and then inside you would deploy code on the fly. And this code would get evaluated by the rules engine, blah, blah, blah. And there were a couple of benefits. The benefit is that the business would be independent of the release cycle. They could go to production, make directly their change, and it would be applied immediately, which can create issues because sometimes the dates, you need to apply the change at the correct date, especially with law, blah, blah, blah. I mean, I don't want to work on the detail because this talk is not about a rules engine, but the idea would be that. And so some businesses would be very afraid to rely on IT, depending on the organization, and they would say, we want a rules engine, and then we want nearly all the code there. The problem with this approach is that, well, IT would be very happy because then it becomes their problem, not yours. But the problem with this approach is the idea of the business changing a rule is crazy. I never worked on such a project, but I asked one of my colleagues once, hey, show me the code. But how does the rule looks like? And wow. So first, I don't believe any regular business person could have changed it. You need to be a developer to understand the rule. And then you need to be also very familiar with the business. So the idea of like being independent is an idea, but it's not a reality. Anyway, this is only one of the ways. My idea is if you isolate the quick changing part or parts, you can replace it with a single microservice, with a serverless function, with a rules engine, with whatever, something that is not invented yet, and keep your monolith working. Do you know this microservices pattern by Chris Richardson book? Do you know the book? Okay. Very, very interesting book, like this thick. I read halfway through the book. He does everything by the book. And then halfway, I understood that nobody is crazy enough to implement everything. So about halfway through the book, I just put it back on the shelf and said, OK. If you want to do microservices the real way, you should read the book and implement everything. It's a lot of effort. Anyway, there is a companion site, which is also very interesting. And in one of them, he talks about strangling the monolith. So basically, there is this like Martin's Fowler design pattern, strangling pattern. And the idea in strangling the monolith is very similar. So basically, you start with a monolith, then you chop one port, which becomes a microservice, then several more ports and ports and ports. And at some point, you don't have the monolith anymore. You only have microservices. And this is a very good idea. But his idea is this is to be architecture. Everything is microservices. That's the grail. Everything is nice. We have achieved microservices paradise. Whereas my idea is, why don't you stop there? So here you just have the quick changing parts, and you keep everything in the monolith, which is very stable anyway, so you don't care. So one way to achieve that is to use an API gateway if you are in a web environment. So you can, like, through the monolith, you send everything to the monolith, and at one point, you just change the routes to one function that is serverless, microservice, rules engine, whatever, I don't care. The best example I have is, like, I've worked in e-commerce, is the pricing. Who has worked in e-commerce as well? Yeah. Retail, oh, the worst kind. And the pricing is the craziest part. Yeah. I didn't work on taxation so much, but the pricing was always crazy. Like, the business always had crazy idea. Like, the regular stuff, like, OK, you buy this product, and if you buy X, you get, let's say, 10% is easy. Then they come with, oh, if you buy X of this product, you can get Y for free. Okay? And then they come, yeah, but if you buy Z of this product, then you get no shipping costs. So every time you wanted to do something, they had more crazy idea. I worked on the Hybris platform that was impossible. So my idea is we can chop the pricing engine and do something fun. And then I have 10 minutes, so it's demo time. And of course, it's the time where I want to show you that it works, and there is a chance it doesn't, otherwise it wouldn't be fun. Chopping the monolith, which is not the right way. Chop monolith. New window. OK, so here I have my architecture. Is it big enough for you? Good. So I work on the Apache API 6 project, so I will be using Apache API 6. Of course, you can use any API gateway you want. But of course, I will be very grateful, my boss, if you used mine, but OK. API 6 depends on etcd, where it stores its configuration. It's a distributed key value store. Then I have my application, which I need to downgrade here. So I can show you the codes. And I have MariaDB, where I have all the data from my project. So who here is a JVM developer? Well, not that many people. OK. So this is a regular Spring Boot application with Kotlin. And the idea is I will start the stuff, and then I can describe the code. Docker compose up. Here, I have this pricing stuff. And at the moment, pricing is super hard. I just add the sum of all prices, right? The idea is not to show you how you can do a pricing engine. It's just to show you how you can change it easily. So I have this pricing stuff. And basically, when I call it here, so I get the cards, I price the cards, and I return everything in one JSON payload, right? So when I go there, so here it should have started, I will just configure the API gateway, so I send everything to the shop. And here is just to remove caches so I don't have bad experiences during the demo. OK, now I can, I need to start Firefox. Yeah, I got interested in this stuff in the Czech language. I don't know if you see it. Sorry, but I won't learn Czech anytime soon. And so I can go to localhost. And I learned something that's not like only the Czech language. It's called syllabic consonants. So that's how you can pronounce all those consonants, and there are hidden vowels somewhere that stupid foreigners cannot know. Huh? So here I add stuff to my cards. I will just check the network, and I go here. And here in one go, I got everything. So if I get here and I say the response, I see I have the total, and I have the lines of my cards. And the origin is a monolith. I cannot make it bigger. You should have seated in the front row. But trust me, do you confirm this written monolith? Of course, thanks. You really want your stickers. I understand. OK, so now to actually start my journey, I will need to make pricing not a regular function call, but an API call. So now the pricing here, and I will just update, so it's Docker compose start chop chop. And normally at some point, I always forget, it's up, it's not start, is up. Yes. So at some point, yes. OK, it's doing this. So the pricing now has become a route. So now I compute the route. So the client, the browser, will first request the content of the cart. It will get the content of the cart, and will make another request to the pricing. This is very stupid. It's not the client that should do it. It's the API gateway, but you understand I'm too lazy to implement further. So now I have this. I get back here. I didn't implement the sessions, so I need to redo everything, but that's fine. I go there, I go there, I go there, and here I go on the cart. So you can see it's another version. And now when I go the pricing, so first I have 2 requests, and here the origin is still the monolith. So now my architecture is ready to be chopped. What I did, finally, is I kept the whole stuff, but I implemented the pricing in like JavaScript, yes, and I put the codes on the Azure FOSS. And so now, the only thing that I need to do, I don't redeploy anything. I just go here, and I still have everything that goes to the monolith, but I have one special endpoint, the pricing endpoint, and I say, hey, when I receive a post request on the pricing endpoint, well, you just go to Azure instead. So I do it, and now if I do like the refresh, like it should be like slower, and then you can see Azure here. And I didn't redeploy the monolith. And now I can change the code every time I want on serverless. And again, it can be serverless or rules engine, whatever, I don't care. But basically, I kept my monolith. So thanks for your attention. You can follow me on Twitter, even though Twitter is now dead. You can follow me on Mastodon, where I'm trying to find new and interesting content. If you're interested about the code itself, because even you should trust this guy that everything was fine, but probably I bribed him or whatever, so you can get the code on GitHub and do it by yourself. And if I got you interested in Apache API 6 somehow, just have a look. It pays my bills to come here, so I can do better talks next year, and I come back again. And now we have like 3 minutes for questions. Wow. Yes, thank you. You really want your stickers, I know. Yeah. Remind me.
I confirm that it was Azure again, so that was the first part. Now the second part is, when do you decide, let's say from your experience so far, when do you decide to stop this kind of transformation from monolith to microservices? Because you said that you read this book and you realize that there is no utopia around all process, so there is a line that you can decide to stop. And how do you motivate yourself to maybe not continue, let's say?
So the question is, when do you stop chopping the parts of your monolith? When do you know what's the right time? So I will completely change the question, because that's my privilege as the speaker. And I tell you the question you should have asked instead. The question is, when do you start chopping? And there is one single reason, in my opinion, to start going to microservices. And it's not about any technical reason. The only reason you should start doing microservices is because you have too many developers working on the same code base. And my experience, and this is very personal, we started to feel the pressure at 70 developers. So we had a dedicated release manager who handled all the branches of the GitHub flow, of the Git flow. It started to get really messy. That's, at this level, we should have started to think, okay, what part can we start to chop? Before that time, scaling, hey, Like Stack Overflow, they don't do microservices, they scale super well. So every technical reason you have to do microservices is probably bullshit, in my opinion. I accept stickers also. The companies that go on the stage and advocate for microservices, they have the right organization, they have many developers, and yes, they are at a point where the benefits of microservices outweighs the problems that you will get, like distributed tracing. But I believe that most regular companies are not mature enough to do microservices anyway. So unless you start feeling the weight of those like many, many developers, don't do it, and we can talk afterwards because I'm out of time. Thanks a lot. I have stickers for everybody. Don't worry. Thank you. And I have a talk tomorrow about OpenTelemetry. It will be less funny, but still interesting, I believe. Sorry? What time? At 11.
but it's on the projector as well. So, you know, you feel free to slide the laptop closer, or maybe you can just stand there, you know, and yeah.
Social events today in the afternoon or in the evening. And right now, here is our speaker, and the floor is yours.
Thank you. Hello, everyone. Welcome to Camel 4, What to Expect. My name is Otávio Rodolfo Pischi. I am a principal software engineer at Red Hat. I'm also a committer and a member of the Apache Camel PMC. You can find me online. I'm usually on Twitter, but you also have my mail here should you have any questions after this talk. In real life, I live here in Brno for 8 years already. Unfortunately, I still do not speak fluent Czech, but I keep trying. On the agenda today, I'm going to give a very brief overview of the Apache Camel project. Then I will talk about the motivations and objectives for releasing a new major version of the framework. I will discuss a bit about the changes under the hood. I'll complement with my thoughts on how you can plan the upgrades, and I'll finish with the questions and answers. The Apache Camel project is basically organized in multiple sub-projects, Camel Core being the largest one of them. It's the one that provides the enterprise integration patterns and components. That is what most of the people tend to know about. But then we also have some sub-projects that focus on specific technologies or specific problem domains. We have things like Camel Spring Boot and Camel Quarkus, and we have also things like Camel K, which focus on providing a lightweight runtime for Kubernetes and OpenShift. If you have never seen what a camel route looks like, I'm showing an example here. This one is written in Java, basically shows how you could pick some data from Kafka and send it to a queue on Amazon SQS. This route could be written here in XML or YAML, among other languages. With the course of developing Camel 3, we kind of created a few new features and projects that they will become more prevalent with Camel 4. The first one of these projects is Camel JBang. Camel JBang is basically a way to quickly run the routes you create. You don't have to actually write a full-blown Java project to do that. You basically pass a YAML file and Camel JBang can run it for you. This makes it a very nice tool for prototyping routes. So whenever you want to try something, Camel JBang can help you on that. Camel JBang also has features to simplify bootstrapping integration projects for our sub-projects, things like Camel Quarkus. You can quickly export those routes for running on those runtimes. And lastly, Camel JBang also provides functionality on which you can implement new things. For instance, internally within this project, Camel Caravan, we use Camel JBang. Camel Caravan is a toolkit for designing routes. Basically, with Camel Caravan, you can use those drag and drop features to select components and patterns and design the integration in a visual way. It basically works as an extension for Visual Studio Code. And Camel Caravan will save the YAML route for you, so you don't have to actually write code. And one of the nice things that it has is this arrow button, which uses Camel JBang to run that integration that you have designed. But I'm here today to talk specifically about Camel 4, what we had in mind when working on this new version of our framework. And when we think about the motivations for working on Camel 4, one of them, and I think the primary motivation, was the release of the Jakarta 10 set of APIs. Camel itself does not use Jakarta APIs, but many of the libraries that we use to implement our components do. So with the goal of being able to upgrade to those libraries, we had this motivation for Camel 4. Then we have another big motivation, which is Java 17. The community of engineers working on the Java language has been, for many years already, developing newer and greater features for the Java language. And we want to be able to make use of those features, both for making our code easier to maintain, but as well as for implementing new features for our community. And then we have a set of projects that are very important for the Java community in general, and they are widely used. We have here things like Spring Framework 6, Spring Boot 3, and Quarkus 3. Those three projects are widely used around the Java ecosystem, And they too are somehow also motivated in releasing new features based on both Java 17 and Jakarta 10. So it came out as the perfect opportunity for us to work on a new version of Camel 4, aligning with all these 5 items. When we think about our goals for this release, what we want to achieve, as always, for when you are working on a new version of a framework, you always think of the foundations you want to build. And with Camel 4, we again fought on building foundations for the future. So that's why we are aiming at supporting Java 17 as a minimum version. As I said, we want to make use of these great and new features of the Java language, both for our work on the framework, as well as for the implementing new things for our community. And we see Camel 4 as a forward-looking release. That is, we are already looking forward to the upcoming Java 21 LTS release, which should be, I think, around September. Should be out, I think, around September. And one last point is when we raised this discussion with the community as having Java 17 as a minimum version, we did receive some feedback from the community questioning whether we could support Java 11. But it turns out that since many of the libraries and many of the motivations that we have are already aligned with Java 17 as a minimum, it would be kind of difficult for us to do that. Looking at our work in maintaining Camel and what we did with Camel 3, things that worked well, things that gave us some additional effort, we identified Camel Karaf, which is one of our sub-projects, as one of the pain points in our ecosystem. So we decided with Camel 3 to downgrade the effort we have on maintaining this sub-project to as a best effort. In practice, this means that we will decouple the releases of Camel Karaf from the releases of Camel Core. So what it means is that when we release a new version of Camel Core, there won't necessarily be a new version of Camel Karaf. In the same kind of thought, we also took this opportunity to work on goals to reduce our maintenance effort. Camel is kind of big project, so as always, a new version is a good opportunity to do that. So we focused on doing some internal cleanups. As the time goes on and on a project that is already 17 years old, there is always some technical debt that piles up. So with Camel 4, we did quite a lot of cleanups. I will elaborate a bit more about this in subsequent slides. We also took the opportunity to look at things that within the Java ecosystem are either being superseded by newer versions or stopped being used. For instance, we know that nowadays most of the projects are already using JUnit 5. So we decided to drop the support for JUnit 4 in this release. And we also took the opportunity to look at the library of components that we have. Camel has about 300 components, a bit more than that. So when we look at the components that we make available for the community and look at both the technologies and the underlying projects that offer the functionality that we use, we identified about 33 of those that either have become unmaintained or were evolving on a pace that was not the same as the rest of the community. And by that I mean For instance, by this point in time, they still do not support Java 17 or have not yet been supporting Jakarta 10 and so on. Things that would kind of make our release more difficult. And as a result of this evaluation, we had 33 components that were affected. Of those, 20 can be easily replaced by others already available in Camel. And here I'm talking things, for example, Camel Active MQ, which you can somewhat easily replace with Camel JMS. And of those components, most of them have shown little usage based on what we could gather from Jira, mailing lists, messages, and chat requests. And one point that is important to highlight here as well is that in some cases, these are temporary. We have, for example, as I mentioned here, Camel Active MQ. The community is already working in resurrecting this component based on a newer version that supports Jakarta 10. So it might be that this number of 33 components affected will be reduced as the development of Camel 4 progress. Talking a little bit about the changes under the hood, these are things that normally wouldn't matter most for the users, but I think it can provide a good insight about the work that is going on. One of these things is what we call the internal plugin manager. Camel internally has a way to allow the configuration of many things, how exchanges are created, how messages are created, how error handlers are created. And this is done through what we call a plugin interface. In Camel 3, this interface was not very uniform. With Camel 4, we looked at the way we were working with them, and we worked to provide a uniform interface. This is something that does not, again, affect the users, but it turns out that reduces the maintenance effort for us. We also look at things that were somehow public but shouldn't be, things like introspection support, which is used only internally. And when not talking about code specifically, about the internal code, there are also changes in testing. For instance, we are aiming at providing clean builds for Power and S390X architectures. This is Linux on mainframe. Of course, Camel runs fine on these architectures, but we also want the community to be able to build and run the tests on them. Again, on the same topic of reducing the maintenance effort, we reevaluated how we were doing some of the testing for our components. The way Camel 3 used to do that was through a kind of complex hierarchy of types to set up the Camel context. With Camel 4, there is a new JUnit 5 based extension that makes it much easier to set up the context. We basically use the register extension, and the JUnit does the bulk of the work for us. Eventually, we hope that this will become something that we encourage the users to do to simplify their part of the testing as well. And lastly, on the part of internal changes, nowadays we know that supply chain attacks has been a big topic, and within this topic of security, many projects are providing the software bill of materials. With Camel 4, we are going to provide that as well. In this new release, one topic that we focused a lot was on the part of performance improvements. Some time ago, it became kind of famous this JDK issue, JDK 8180-450. Basically, simplifying a lot here, this issue is related to a performance penalty that can happen when you do type checks. If you're working on any application that is performance sensitive, I strongly recommend looking at this material that I'm showing here, especially cracking the scalability wall, which was a talk given at, I think, DevOps UK, where two of the engineers that worked a lot on uncovering this issue and working around it talk about the implications of this issue, what was done to solve it, and why Java developers should care about it. As we worked to work around this issue and fix the problems that we identified as part of that, we optimized several components on Camel, notably CIDA and Disruptor, with, of course, some changes also happening on core, which benefit basically all the 300 components that we have. And of course, as during the course of investigating these performance issues and working to correct them, we came out with other micro optimizations that alone wouldn't do much changes, but in aggregate can provide some nice performance improvements. And to showcase a little bit about what I'm talking about in terms of performance improvements, I'm going to show a few examples. For instance, on the case of CIDA, which is a component that is kind of widely used, in a scenario with low contention, we have 19% faster throughput with Camel 4. On a scenario with 4 consumers and 1 producer, 18% faster. With a little bit more contention, 8 consumers and 1 producer, 51% faster, and so on. Also, Disruptor is another component that is also used, especially in scenarios where you have multiple producers. On the case of Disruptor, we have 36% faster results with Camel 4, and so on. Overall, what we found out is that Camel 4, in our tests, it was 80%, it was faster 80% of the times for the CIDA component when compared with Camel 3.20.4. For the Disruptor component, when compared with 3.18.6, Camel 4 was faster 80.6% of the time. And with comparing with 3.20, Camel 4 was faster 91.9% of the time. If you are interested in learning a little bit more about the performance improvements that we worked on Camel 4, I suggest looking at this blog post where we discuss a little bit more about the changes that we did, what we found out, some of the metrics that we gather, and more. I hope that by this time I kind of sold you the idea of Camel 4, and I hope you are all excited about upgrading to this new version. It is not, the final version is not out yet, but we already are working on a release candidate. We have a few milestones available already. But what should you expect of a migration from Camel 3 to Camel 4? Well, first of all, the migration from Camel 3 to Camel 4 should be much easier than was from Camel 2 to Camel 3. We are aiming for a drop-in replacement. Additionally, you should not expect any kind of DSL's incompatibilities. Camel has, I think, quite good track record of retaining this backwards compatibility, and it should not be different this time. With regards to the planning, one thing that might change a little bit is what kind of packaging of Camel you are using. If you are using a downstream or a commercial distribution, do talk to your vendor. They may have their plans already. If you are using the upstream version, the open source one from Apache, the usual recommendations for any upgrades matter here. Save time for testing. We do our best to ensure that Camel has a good testing coverage, but there's only so much we can cover. Do plan to provide feedback to the community. If you try the upgrade, something is not working, do share that with us. Do open tickets, go to our mailing lists or chats, and provide the feedback to us. And share the knowledge with the rest of the community. The problems that you face today might help someone else going through the same problem in the future. It also helps us as a community to learn from the problems that the community is having, and with time, as we work on other versions, other features, we can learn from that. The path for upgrading, the path to Camel 4 might depend where exactly you are. During the course of developing Camel 3, there were a few important milestones in terms of what we achieved. For instance, the first version where we officially supported Java 17, the last version where we supported Java 8, and so on. So things like this might matter as well on your upgrade plans. In general, as I said, migrating from Camel 3 should be relatively easy, especially if you are using maintained technologies. If you have some component that's not going to be removed or have been temporarily removed, that should be a good sign as well. If you're using one of the modern projects that we have, Camel Spring Boot, Camel Quarkus, Camel K, migration should be fairly simple. If you're using the plain Camel Core, a good sign is if you're using a relatively newer version of Camel 3, especially a relatively newer LTS version. A bit more effort might be required if you are using an older LTS version, especially older than 3.14. Not because we broke features or because some incompatibility along the way, but because of the cost of many small changes aggregated all over the time. And some code changes definitely will be required if you are using those internal APIs that I mentioned that were changed. I don't think, I think many in the community are not using those APIs, but if for any reason you are, then do prepare for some code changes. Those changes also should not be so complex, but of course is something that will eventually change. If you are using OSGI, as I said on the beginning of this talk, we are downgrading our effort on Camel Karaf to a best effort. So ideally, you should plan to move your OSGI workloads to Camel Quarkus, Camel Spring Boot, Camel K, Camel Kafka Connector, any other project that might suit your needs. A few user impacting changes, which should not be widely impactful, are, in terms of logging, with Camel 4, we upgraded SLF4J API to version 2.x. This version brings a few different dependencies. So depending on what you use as a login, you might need to adjust a little bit the dependencies that you use. One of the exchange patterns that we had and was not widely used, called in-optional out, was removed. And for those using the camel main and using a main listener to configure the camel main, one of the methods that was used to perform that configuration, the method configurer, was removed. It was already deprecated on Camel 3, and with Camel 4, this method is not available anymore. For those users, they should move to either the after configurer or the before configurer methods. If you are still on Camel 2, then that migration path is a little bit more problematic. First, Camel 3 was modularized, so the dependencies that Camel 2 provided are different than the ones provided by Camel 3. So migrating from Camel 2 involves adjusting those dependencies and package changes and so on. There were also changes in terms of handling multiple and single contexts, and Camel 3 also brought a Java 11 as a minimum version. So it's quite a lot more work than the migration from Camel 3. Closing this talk about Camel 4, I leave these comments that even though Camel 4 is not out yet in terms of there's no a fully stable version, we already have several milestones available. Our release candidate is planned for just a few weeks in the future, so do start planning now. Do plan to adjust your applications, see how they work with Camel 4, and provide the feedback to the community. Avoid unmaintained versions. We still have many users on the community, either using very old LTS versions of Camel 3 or even using Camel 2 completely. So please do plan to upgrade those. We are not maintaining those, and the community is not receiving fixes for CVEs and bug fixes at all. Reevaluate usage of old technologies and standards. If you are integrating with some tool that has become unmaintained, that's something you should look at your architecture and see what you can do to move away from that, because there's a good chance that the component used to integrate with that might not be available in the future. And as I mentioned earlier, please share the knowledge. It helps the whole community. It helps us to learn what we did well, where we failed, and we learn to do better in the next version. And with that, I think we are open for questions and answers if there's any.
What about the Camel-based Kafka Connect connectors? Are they still planned for Camel 4? Or?
Yes. So the question is, what about the Camel Kafka connector if it's planned for Camel 4? And the answer is yes, it's planned for Camel 4. He worked the Camel Kafka connector on the course of the development of Camel 3 so that it uses camelets. And as we progress with development of Camel 4, we will certainly work on a new version of Camel Kafka connector that makes use of Camel 4 engine and the new Camel camelets that will become available. Welcome. Any other question? So thank you, everyone.
Test, test. Okay, works sort of. I hope so. I can't hear. Outside the door. Thank you. I'm Paolo Beni. I work for Red Hat in the networking services team. I used to add back to the UDP protocol implementation inside the kernel. Then I moved to add bugs to the MPTCP protocol implementation inside the kernel, and I currently mostly get blamed by Linus.
That is, he is one of the upstream maintainers of Networking 3. And I'm Marcelo. I also work for Red Hat in the networking services team, and one of my main responsibilities in the past time, recent, it's on integrating OVS hard offloading in our products.
Today, we are going to talk to you about networking performances. Great. It's full. Oh, great. OK, so we are going to give a very brief introduction about networking performance in general, and then we will focus on, on a couple of case of study that we use to demonstrate some interesting, strange results, how to investigate them using common tools, and perhaps how to improve things in some cases. And we will draw some conclusions, hopefully. What's the big fuss about networking performances? In the end, they boil down to measure the maximum amount of packet per seconds or message per seconds, or the max throughput that a given host is able to process, usually on a single core. That is mostly by convention, because we hope that things will scale on multiple cores, even that is not always true. And also because the setups are much more simple when we use a single core. That is, in turn, actually unfair with respect to some architectures that have less powerful GPUs, but possibly much more cores available. Why we do performance testing? For many good reasons. To detect bottlenecks, to avoid regressions, to tuning setup, etc. So when we speak about performances, we are not interested in functional behavior. We assume that everything works just as expected, and we instead are interested in raw numbers. For that, we avoid using well-known and very useful tools like TCP-Dump, Wireshark, PacketDrill, etc. And we instead focus on using packet generators, either in user space like iPerf or NetPerf, or kernel space packet generator like PacketGen. That tools usually provides the statistics we are looking for, but more often than not, we need to have other aggregate counters that the kernel can provide, and we can inspect with other tools like netstat that gives us per protocol aggregate counters, or socket stats that give us per socket information. And more often than not, we are interested into looking where our CPU cycles are actually spent, and today we will use a lot the perf tool. So let's move to the case of study. The first one is a very simple one, that is receive throughput for an UDP application. Why this one? Because it's a very common thing that most even telco does. First thing, how fast we can go. Let's measure how many packets we are able to receive. The step is very, very simple. We have a host that runs a packet generator, in our case, PacketGen. We use PacketGen as packet generator because we don't want the transmitter being the bottleneck. We want to measure the performance of the receiver. The receiver runs on another host. It's a very simple UDP application. Here there is the URL where you can find it. Just read packets and drop them. We use that one because it a lot of command line options that can be used to configure its behavior. The two hosts are connected by a fast link, 10 gigabit in our case. the faster the better, and we are using 2 Mellanox NIC on both the sender and the receiver. Whatever hardware you are going to use for this kind of experiment, you will have slightly different figures, but the whole trend should be the same on most recent server class hardware. So we want to see how fast we can go in this scenario, how many packets the receiver is able to process, and we want to get some stable results. For that, we are going to pin the user space process application on a given core, and we are going to pin the kernel space processing on another core. Also, we are going to disable IRQ balance that could move the kernel processing on random cores unexpectedly, make the figures we measure sort of random, and we want to avoid that. So that given, we are going to do the first test with a somewhat random, somewhat default configuration. The only perhaps unusual thing is that firewall D is disabled. Yeah, we don't have net filter IP tables rules. And this is what we see. 1,660,000 packets per second, which is not bad. It's quite higher than we would have got a few years ago with the same hardware. But we want to understand if that is the maximum we can get. So we attach the perf tool to the receiver. The perf tool can measure how many cycles are spent in any function executed by a given core, and we report that. And we are using a command line report. The main information there are the name of the function, where CPU is spending cycles, and the percentage of CPU cycles spent in every function. You can see that most of the time is spent copying data from the kernel space to the user space. Not that many times, roughly 20% of the whole CPU time. And we can see that below that, the 4 topmost offenders are function related to syscall overhead, let's say. There is the libc receive message syscall, which is the syscall used by the application to actually fetch the packet from the kernel. And the other ones, instead, are related to security countermeasures for recent hardware vulnerability and to the Linux security tool inside the kernel. So the bottom line is that we are spending a lot of time due to syscall overhead. And the application is receiving 1 packet for every syscall. So we could think that if we use a different syscall that allows us to process many packets with a single call, we could save a lot of time and possibly going faster. This syscall actually exists. It's called receive M message, where the first M stands for multiple. And we can change the behavior of our tool with a command line argument to tell it to use such syscall. So let's do it and measure whatever we see. Surprise, surprise, we are slower than before. Miserably slower than before. And that is quite unexpected. We hoped to go slightly faster. Why? Simply running the top command line tool gives us some information, somewhat. As we can see, in the first experiment, the user space process took 88% roughly of one CPU. And now it's taking much less. So we are really go faster. But still, we are processing less packets. Why? Because the bottleneck is not, in this case, the user space process. The bottleneck here is the kernel space processing. The other process you can see in the top report, case of RQD, which is keeping a CPU fully busy. Still, we are faster. Why we see less packet? Because to actually walk up a process, the CPU needs to spend some cycle. The faster is the user space process, the more frequently such process go to sleep, more frequently the kernel space process need to wake it up. And more CPU cycles has to spend to wake that process up, less CPU cycles that CPU has available to actually process packet. So the bottom line is that with our first report, with our first perf tool investigation, we have looked to the wrong CPU. We should have looked to the other one, the one processing the kernel space stack. So let's look at that now. And this is what we get. And we can see that the topmost offender, the function that is burning more CPU cycle, is that inet GRO receive. And we have another function still quite high in that ranking with that GRO word inside. Both of them are related to the GRO engine. The GRO engine is a very lower component of the networking stack, is in charge of aggregating as much packet as possible as seen on the wire in a single giant packet that will later traverse the whole networking stack. That kind of technique allows the networking stack to save a lot of CPU cycles when it's able to aggregate packets, because as many as 40 wire packets will be processed by the networking stack at once. The bad thing for this experiment is that the UDP protocol does not leverage GRO by default. So that cycles are actually completely wasted. What we can do, we could disable GRO. That is a thing that we can do in this experiment because we are interested just in UDP. In general, it's a bad thing to do because there is also the TCP protocol, which is widely used somehow. And if you disable GRO, TCP performance will sink dramatically. Anyhow, we can disable it via the ATH tool with the command line reported over there, and we can repeat the experiment. And finally, we get some progress. If you compare the number with that we had on some slide ago, you can see that we get some miserable improvement with no change at all in our code, just with a somewhat better configuration, at least for this test. Still, we have some surprise. There is what the perf tool is reporting now as the topmost offer for the kernel space processing. And as you can see, that is completely different from what we had before. Yes, the GRO thing is gone because we disable it, but the other function have just random number with respect with what we have before. Very different CPU usage. Why? Because when we process a packet coming from the net, no matter what we do, we will have cache misses for every given packet because the packet contents are fresh, are just put into memory by the DMA engine, and that memory contents for the CPU point of view is completely new. That means cache miss. That cache miss before happened in the GRO engine, and that was one of the reasons why it was so costly. Now the GRO engine is not running anymore, but still we have that cache miss, and whatever function is actually experiencing that cache miss is getting its cost exploded, sort of. So we are still interested in see if we can improve the throughput sometimes. Down the list, taking very little CPU cycle, we see that UDP v4 early demand function. Even is taking very few cycles, that is somewhat relevant because that early demux function is trying to look up for a connected socket for each incoming packet to avoid later root lookup. But in our experiment, the UDP socket is not connected, so that very little amount of CPU cycles are completely wasted. And we can avoid that with a simple sysctl, disabling that early demux functionality. We execute the sysctl, and we repeat the experiment. We hope to see some improvement. And we see that. And unexpectedly, that's a huge improvement, 10%. That's, whoa, we just removed a little overhead, and we got a relevant improvement. Why? Because for lied blatantly, the figures are not that stable overall, and they are not that stable because power management is enabled on the host we are using, and power management kick in at an unexpected moment, and when it kicks in, results are sort of varying. Anyhow, the trend, repeating many tests, etc., the trend is like that. If you disable GRO, you will see an improvement. If you disable early demux, you will see another improvement. We are still interested in maximizing our throughput. And we can try something slightly different. We say that we can first look again at our perf report and notice that there are a few functions that are related to root lookup, and they are consuming quite a bit of cycles. And we mentioned it before that early demux functionality could avoid the root lookup. So we could try re-enable it and change our user space tool, change the configuration of our user space tool to actually connect the UDP socket upon reception of packets. That can be done only if the ingress UDP traffic is just for a single flow. In our experiment, it's just for a single flow, so we can, single flow meaning a given L4 tuple. UDP IP source, destination, sorry, source IP, destination IP, source port, destination port. So we re-enable early demux, and we change the configuration UDP sync and rerun the test. And great, we see a relevant improvement. We have moved to more than 2 million packets per second from the beginning 1.6, which is more than 20% improvement, and with no changes at all to the code of our application, just a slightly different setup. If we go back and look at the top tool output, we see that now both CPU are fully busy. So we may conclude that we are at our journey. No more performance improvement are possible. And that will be false, because we mentioned it at the beginning that GRO could give a great booster to bulk transfer, and GRO is not enabled by default for UDP, but can be enabled on a per socket basis if the application creating the socket requests it. UDP sync does not support that option, so no figures, no real figures for that, but if you fetch the source, modify that to enable UDP GRO, which is a simple set sock option, and then use receive M message, because at that point the bottleneck will be back on the user space part, then you will see something with this hardware around 3.5 million packets per second, which is much more than what we see now. That will be the end? No, because if nobody from the security team is watching, you could try disabling Linux and possibly disable also red line and security mitigation. I'm not suggesting to do that. You can do that in controlled lab, where everything is under your control and your responsibility. And if you do that, you can probably reach something around 4 million packets per second, which would be almost 3 times the initial figures. And that would probably be the greater number you could get for this kind of hardware. And with that, I leave.
All right, thanks, Pablo. Moving on to our next case of study, I'll be covering the situation on which we partially use the hard offloading that we can do with OVS and TC. So yeah, completely different from the use case before. I'll briefly explain how OVS hard offload works, because that's not really common yet, but I'll assume that you know how OVS works. Here we have a picture on how a standard OVS works. Packets are coming through the NIC, they go through OVS, and then they connect to network namespace using vEth, right? So that's pretty standard. With hard offload, it leverages SROV. It creates virtual functions in the switch dev mode, on which the flows, they are processed in a programmable way, unlikely from the legacy SRV model, on which the card itself does many things on its own. So that's the benefit of using the switch dev mode. And then the picture comes like this. You have the NIC, you have the network namespace, and assuming that this flow is already offloaded, packets come directly from the wire into the network namespace, and vice versa. This is the fully offloaded way. And then when we go to the half situation, which is, for example, when you are doing contract, you are doing decapsulation, but for some reason you can't output to a virtual function inside the network namespace, so you have to use a vEth tunnel. The card can't output directly into that, so it will offload all the processing up to that moment, and then it has to resort to a software fallback to do that. So in the picture, it's pretty much the same thing, but the last step going into the network namespace is not offloaded, it's processing hardware. And then on the way back to the wire, it's entirely done in software, because when it's coming from this vEth tunnel, it's impossible to do offloading at that time. The network card user was a ConnectX-6DX. The sender was a Rail 8, receiver Rail 9, so it's very, very fresh. The test was simple TCP stream with a perf. Test results that we got here. We're testing just with TC data path. Then we're not using OVS kernel, but we're leveraging skip hardware switch so that we can say, okay, run entirely in software, or leverage offload whenever possible. And the idea on trying to leverage this partial offloading there is that using dedicated hardware is usually better than using a generic processor for doing the computational work. And at the same time, it's creating some parallelism quite out of the blue, because when the card is processing a packet, it finishes, delivers to the OS to do the last remaining part, and then it's already processing the next packet. So you're getting some parallelism for free in there, right? So we should get a performance bump, but not. Something happens. We get a worse performance than doing entirely in software. So what's happening here? Why did we go from 18 to 11 gigabits per second? That's quite a drop. And if we check, this is entirely software. We are using skip hardware on the sender side. We can see the CPU usage is quite okay. No CPU is being maxed out, no bottlenecks here. On the receiver side, though, yes, we are maxing it out, so the receiver is the bottleneck. And then if we move to the half offload situation, on the sender side, still not maxing out CPUs. And on the receiver side, still the same figures. So what we can conclude from here already is that when we go on this half offload situation, apparently on the receiver side, we lose 50% of efficiency, because we are using the same amount of processing to do half of the work. And then we don't know what's going on, so let's start top bottom. First thing, check TCP stats to check if things are going right or wrong in there. Do you see something off in here? I don't. Because there are no retransmissions, there are no drops. It's just, it's really clean. But the numbers are lower, so the problem doesn't seem to be on TCP. Let's move down. This is on software. We have our baseline, that is this one. We are not debugging and trying to make something just better, but we are comparing A and B. And this is one output of perf. Unlike on Paulus, the left column in there is the accumulated time, accumulated CPU uses that these functions and its colleagues are using. And nothing stands out, although this is the baseline. And when we try to compare to the half-of-load situation, it's not too different. So how do we move on from here? One idea is pick one, right? No, with previous knowledge, we know that this function is quite important. It's the one that gets called in the driver when it's processing a packet that the NIC just delivered to it. So we can dive into it. And if we didn't know that, we can go on over every function. It will take a little bit longer, but it will get us there. And then we expand that view. We have these differences. Here, it's the software one and the hardware half-offloaded one. Okay, we can see it's doing more stuff and different stuff in here, but at the same time, we don't have a good idea on what these numbers are meaning. Okay, it's using less, spending less CPU time on NAPI GRO receive, but what does that mean? We can't make some sense out of it yet. So, finding bugs, it's harder than finding Waldo, right? When we go on checking, trying to understand what those numbers mean, these screens, they are counting how many times these functions are getting called. And during this experiment, this one here, NAPI GRO receive, was getting called 7 million times. And as Paulo was explaining, this is the function that coalesces packets into a bigger one that the networking stack will process later. And when we go half of load, it gets called 4 million times. And if you do the math between these two, it's pretty much the drop that we had in the throughput. Okay, well now we are starting to talk. And the other two functions that appeared, CT restore flow and wrap TC receive, they are also getting called that much. It was called a lot in here, but previously it just returned it, so it was a blank call. But now we have them quite present in there. And if we are half offloading, interesting to note that the contract in here didn't get entirely removed from it because we still have calls for it that are legitimate in the software processing, even though that is half offloaded because the transmit path is not offloaded, right? And also we have calls for it inside the network namespace. So yeah, it's really not easy still to make some sense out of these numbers. So let's move back to this window and then let's expand it because now we have some more knowledge on it and it makes it easier to understand it. When I expand this function calls, we can see that because of the fallback to software, what it is doing is, in order to restore the contract entry, it is doing packet header dissection at the driver level, which is before GRO. It's consulting XArray 2 times. It's doing memory allocations 2 times for XB extensions and for the tunnel destination. And memory allocations, as you may know, they are really not cheap. It's consulting another RH table. And this is all getting done before GRO. So the driver will do all this stuff for this packet, and then we'll give this back to the GRO engine, which will realize that it belongs to the previous packet, to the same flow as the previous packet, and we'll merge them. And all this effort, it was needed to do GRO, but it's not discarded because it's part of this bigger packet. And that's why recovering this meta information from the packet that was partially processed by the hardware is actually more expensive than doing it entirely in software. In software, if we were doing it, we don't do any of this, and we just aggregate the packets and do it only once. So you're talking about a trade of doing 40 times of this to then aggregate a packet and throw it to the network stack, or just process them, aggregate 40 times, and then give to the network stack. So it's another attempt on getting some benefit of the hardware that backfires. Proper solution for this would be either avoid the situation or wait for the hardware vendor to support GRO hardware flood so that we can have the network stack and the hardware more aligned on how they work. Some conclusions on it is when dealing with performance expected and unexpected, things may backfire and you may have more work to do. It hardly is something that, yeah, just flip that knob on and it will be fine, because it really depends on the use case that you are working on. There's no size that fits all, so you can try to optimize the system as bad as possible for this use case, but for the other use case, it's different. And it may work, but it also may not work, and it may work worse than if you didn't have done these optimizations. And there's this one tool that pretty much rules them all, that is Perf tool. If you check the main page, it supports a lot of stuff that can help you. You will likely need some knowledge into the kernel, into the drivers, into the many subsystems that we have in there. But it's a very helpful tool that is very worth your time to understand it. And that's it. Any questions? I think we confused them all. Yes, please.
Without Selenium, sorry, let me repeat. Regarding the first use case of study, I say that we could have better performances without Selenium. Yes, that is actually well known, but don't tell Paul Moore, which is the Selenium maintainer. Well, he knows actually. If we go backward a little bit, one of the first slide, here, you can see the fourth topmost offender is that Selenium socket receive message. That is the hook used by Selenium to perform and enforce its policy. If you disable Selenium at boot time, not making it permissive, like adding Selenium equals 0 on the kernel command line, that function will not be called at all, and that overhead will go away. Here is 3-something% at greater packet rate that we can obtain with UDP GRO. That will be more visible, and removing that, you will get some some relevant gain. But don't do that.
Try to shut down the cache lines while you're receiving package.
Excuse me, can you repeat the last part?
Have you tried to disable the cache lines when you are receiving packages and actually skipping the hammer of the cache lines?
Okay, so the question regards cache utilization. I mentioned that processing new packets will experience cache miss, and it suggests to disable caching for the packets to avoid that cache miss, if I understood correctly.
Yeah, you can turn off temporarily the CPU cache.
Yeah, but that will not solve the problem per se, because we see the cache line, the CPU see the cache miss, because the CPU has to access the data, for example, to fetch the MAC address for Ethernet processing, the IP address for IP processing, etc. So if you don't have the cache in between, we have to go all the way down to the main memory and spend a lot of CPU cycles. So in the end, it's exactly the same of having a cache miss there. Other questions? No, sorry, out of time, sorry. Thank you.
Hi, I'm blah, blah, blah. Sound is okay or not on the stream? Okay. So, hi, I'm Pavel. I am on my 5th DevConf, and I have my presentation as a web page because I will be speaking about web APIs. So I have decided that probably it will be better to do everything such as you can try it by yourself, because I could mock up something or something like that, but you can try, and you can try everything I will be doing by yourself. I will be talking about the most interesting browser and web APIs. How much of you are the web developers? I will ask. Yeah, like half of the people. And how much of you are programming in JavaScript or TypeScript or doing something like? It's funny that it's a little bit more than the web developers, because now the JavaScript isn't only for a web, and I will be a little bit touching this topic on this presentation. And how much of you has used some special, unexpected, weird thing on the web, like, for example, VR on the web or augmented reality on the web? Yeah, so you are in a good point, because I will be talking about this, about how to make strange, weird things directly in the web. This is the address on the code if you don't have a scanner, but the first thing is I would like to distinguish between the web API and some API web service, because these are totally two different things, but they are often mixed together. The first thing that probably most people will be thinking of when I say the web API, they will think about, for example, OpenAI API, or some Facebook API, or Weather API, or some service which is somewhere in the cloud, and you are getting information from there. But this is actually not a web API. I will be talking about different kind of API. I will be talking about the capabilities which has browser in itself on the device locally without the internet, and which can be used by the JavaScript to make some cool stuff. Very often happens to me the one thing. 5 years ago, I was here at DevConf, and my friend Michal wanted to show something cool. And back then, the most cool thing was the virtual reality. It is a little bit surprising, but yes, 5 years ago, the virtual reality was like, I don't know, like AI today, kind of. And we were thinking that, yeah, we can go to DevConf and put here some Windows PC with SteamVR and show something, but it will be a little bit weird to have in a Mozilla stand in a DevConf, which is organized by Red Hat, the Windows computer without any connection to this conference. So we have figured out that we can use the VR directly in the web. And we have there a stand, and people can try our very, very simple game. And the main reaction was like, wow, this is cool, and this is really running in the web, in a Firefox, in JavaScript, but like JavaScript is the language for validating forms and alerting stuff or something like that. And they were very surprised that this actually can be done in a JavaScript. And I would like to show you in this short presentation what interesting things can be done directly in the JavaScript. There is actually an official page in MDN which lists all the web APIs, but they are very, 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 very long list of them, and I need to pick some. So this presentation is very subjective. And probably I will talk about 6 of them, and maybe there is some more interesting that I will mention, and maybe there is some more cool or more capable or more updated, because actually it's out of my capability to know all of them. But you can definitely go through and yeah. I have picked these ones. It was also on the description of the presentation, and I will show what each of them can do, what are drawbacks of these APIs, and what type of applications you can program with them. And this is the first slide that I don't know actually if it works through the HDMI cable, but if not, I have it on my mobile phone. Oh. I will probably do a thing that...
Hello, DevConf participants. Nice to see you at the talk about browser API, such as...
Yeah, so this is like the live demo of one very strange drawback of this, but probably I will run it on my phone because it's certainly loud.
Hello, DevConf participants. Nice to see you at the talk about browser API, such as me, a speech synthesis API. This is an example of such an API, speech synthesis, directly in your browser. I am looking forward for the following social event party.
Yeah, and this is actually the script which says this is actually this script. There is nothing more. If you copy this into the HTML and put it into the script text, this is actually the thing. There is like speech synthesis is a bit old thing, but when I want to do these things, for example, 5 years, 6 years, 10 years ago, I would need to use some external service. I would need to get some API key, set up my server, do there some configuration. I would need to put a lot more work to do this functionality. Nowadays, there is a standardized API to synthesize voice in the browser. There is a drawback. Drawback is that the standardization is not like not one-to-one what it sounds. It's like one-to-one or what should be sound. And some systems doesn't have, for example, English synthesis. Some systems doesn't work properly on all languages. Some systems are male and some are female. You can list the voices. You can do the thing that you are look through the available synthesizers and you pick the best one, but you have no guarantee that there will be a synthesizer for your language and for your gender you want. But you can be pretty sure that for most of the devices there is an English voice for synthesizing. So for the English application, this is a very, very useful thing. There is an equivalent API which is called speech recognition, which works the other way around. But it actually needs a permission, because it will be a little bit scary if the web can directly listen to you and transcribe the thing you are saying and send it somewhere. So when I click here, run. Oh. Actually, I have some problem with my notebook, so I need to. Yeah. So never mind. But it will do the thing that it will ask for the permission, and never mind. I think. I don't think so. Or maybe I can try. Neřešme. Probably not. It's like this is one thing that I have that I will mention in the next slide. But the thing is that not on every browser it is working, and not on every browser you have permission to do it. So if we want to use probably any of these APIs, you should check the permissions, and you should check that actually you can do it. You cannot rely on the thing. I will show it on the next slide. Here is the accelerator. This is another API or another set of APIs which can detect the surroundings, like the device orientation. It means whether the device is on the top or bottom, or how it's facing. It can detect acceleration, and it can detect much more things. I am listing here 4 of them, but for each of the APIs I'm showing here, but code is only for the accelerometer. You probably should to detect if there is or isn't the actual thing, because there may be not there. You can try to look at the page which is called caniuse.com, and you can put there name of the API, and it will show you like the 95% of browsers is supporting the accelerometer API in the Czech Republic, and then you can decide if you want or don't want to use the API. And there are a lot of them, and a lot of them has pretty nice usages. The obvious usage of these APIs are for the games, and I will be using such a thing. Yeah, this is the thing I have mentioned in the first place. There is a way how to use virtual reality and augmented reality directly from your browser. There are 3 APIs. It is a bit confusing, but there were in the past API which was called WebVR API. This is now deprecated. It works somewhere, but it's deprecated. And it was replaced by WebXR API. And WebXR API is the way how to unite through one standard all the devices like the virtual reality headsets, augmented reality headsets, mobile phones, and probably the new device from the Apple will implement it also. I don't know, but I think. I actually don't know what will happen if I try it here, but I can show you the thing on the device where it's supposed to be testing. When I don't know if it's you doesn't need to see the text, but do you see the button? Yeah. When I say run, it's like detects that this device has registered Google I don't know, Google Cardboard glasses. It's called that, and it sends the thing into the Google Cardboard glasses, but actually. To do there some real thing or to do there some real 3D stuff, it's probably better to use some libraries. Yeah, this is like this code running in this screen. When I run it on the device, it will turn on some detecting mode, and I can see the stars. But this is the thing that a lot of these raw APIs has in common. That you can use them directly. It's this thing. This you don't need anything else than this code to like start the VR experience. But there will be nothing. There will be some default setup and nothing else. Or you can use some framework which will enable you to do their stuff without knowing things like shaders and rendering pipelines and so much things that they will probably be up to one day of the DevConf and one day of the workshops here to do such things. When you want to try to do some AR VR stuff, I recommend Babylon framework or A-Frame framework. Babylon framework is imperative. It's like you are programming the thing. You are telling, put here the square, put there a controller, put there a light, put there that thing, and do this when the user clicks on that. And the A-Frame framework is like HTML or SVG, but for 3D. You have XML code which defines the scene, and you can define by XML. Here is a cube. Here is a circle. Here will be the wallpaper. Here will be the skybox. This is pickable. This is static. And you actually don't need to know the programming. You can just design it by the coding or by some editor. And this is the thing that you have seen that on my mobile phone it's tried to attach on the sensors, so it was like more interactive. On the notebook, the notebook hasn't have these sensors, so it's fall back on the classical game 3D mode. And the framework is doing this work by yourself. Yeah. This is like the a little bit weird maybe that I'm telling about this in the presentation which I'm mentioning, for example, WebVR or the speech synthesis, but one thing in the JavaScript was very, very, very big pain, and it was working with the dates and the formatting stuff, and there were totally messy and non-useful stuff there. And but nowadays there is a pretty useful and very widely supported API for manipulation with the text strings, which you can use, and you don't need to include there any library or some other stuff. You just tell, hey, JavaScript, format me this object to that format, and it will just do it. And yeah, and the thing that's a big thing in a JavaScript, that when you have all the things that I have shown you, maybe not the VR, there is some rendering in the WebGL, but all the things which are running in the JavaScript are running in a one thread. It's like the one threaded process, and you are a little bit limited with it. But nowadays you have some options how to offload the work onto the second thread and the third thread, and you can make a proper multi-threaded application. And there is a thing called web workers. I don't know how much of you have heard or used web workers. Yeah, like a third of you. Web workers is the thing that you can run the secondary thread in JavaScript, and you can send messages between the main thread and the second thread, and you can do some hard work there. You can, for example, compute there some very heavy stuff or something like that. And nowadays there is an API for doing the hard work stuff, but in the canvas. It's pretty useful when you want to render some very, very, very heavy stuff, and don't want to mess the whole UI. Because when you are working in the main thread, you need to do some interpolations with animation frames, and you need to stop and to settle up the UI and do there some strange stuff. But if you use this, you can do very hard work in the worker, and when the worker is ready, it will send the message into the main thread, and the main thread will show the result, and everything is working very seamlessly. I was thinking about what else I can show you, but there are so many things. So probably now I will ask you if there is some things that you are interested in the JavaScript or in the browser you want to do, because there are so many things and so little time to present it. So I will ask you what you yeah.
You mentioned geolocation. Is there also a compass so you can tell which direction you're facing?
Yeah, there is a compass. There are multiple sensors, and you can list all of them in the MDN page. And yes, there is a compass. And also the important thing that there is also a geolocation, and the geolocation is the separate permission. When you allow for example, gyroscope, you need to separately allow geolocation, like where you are, because it will be yeah, I have I have 10 minutes or 5? Yeah. So maybe. Yeah, yeah, definitely. It's like it's like the framework Babylon, which I have shown here. It's combining a lot of things together, and it's also combining a camera. But you can access the raw camera as an API, and you can do there pretty everything you can do in the application. You can program proper camera application in the web, which actually does everything that as the normal application. And also, there are very good APIs which can work with the streams, which can take the camera and stream it somewhere, or take the camera and process it and do with there some stuff. And that's the thing I have. I've prepared here. When you are using the camera, there is one thing that JavaScript or the browser cannot do, but it's not about the capabilities. It's about permissions or sandboxing. The JavaScript from the browser cannot modify the files on your system, because it will be weird that you actually cannot do directly on the web, for example, file explorer or something that is saving the files. But there are ways. The one way is that you can emulate the downloading. You can actually create the file, for example, from the camera or PDF file or I don't know, whatever, and you can bundle it into the file and emulate the download of the file, and the file will be downloaded, but not from the web, but internally, like from the JavaScript. And also you can open the file picker box. It's like you can tell the user, hey, now upload me here some file, but you actually don't need to upload it somewhere. You can process it in the JavaScript. But in this situation, the permissions work like when you click OK or open or whatever is the submit button in the file submit form, you are giving the permissions to the JavaScript that can read this file. Before that, JavaScript cannot even see or doesn't have any information about your files. Yeah.
Okay, what is the overhead of the web browser
Yeah.
on top of the? When I
Yeah.
want to, for example, stay from the camera,
Yeah.
I can do it by the app, and I can do it through the web browser, obviously.
Mhm.
What's the overhead of this?
Yeah, it's a very, very good question. It depends on what API you are using. Yeah. Question is, what is the overhead of the JavaScript? And it depends on the type of the API you are using, and it depends on browser. Some are more efficient than others. But for the heavy work, like for example when you are computing NumPy in the worker, it's percentually slower, but it's not like it's not totally different. It's like I think 60% of the performance of the C or something like that. It's not definitely the like 100% or so. If you want to do very, very heavy stuff, probably JavaScript isn't the option. But when you are doing probably anything else, it is okay. Yeah.
To the sheer size of all the possible web APIs that you showed, I don't think it's really viable for anyone to just remember all of these or know exactly how each works. I wonder, is there any tool or source that you would recommend to look at what people are actually using, what recommendations are, or
Yeah, the question is how you can know that there is some cool API there, and or where you can find the new APIs. I think it depends. You can definitely go through the manual and the new things, but it is not a. For me, it is not a good way because there are so many things, and you are a little bit confused with them. I am every time I see something on the web which surprises me, I look how it is done. A lot of the things I have discovered, it was like I was browsing the web and I have seen that there is a web which can transcribe your voice and put the voice into the video and then download the video as a different format than you upload it there. And I was like, what? There must be something on the server. And I have turned off the internet and seen, there is nothing on the server. It's running in the JavaScript. It's a web application. So I have studied what was the thing which is doing this feature, and I have seen. And the second source is the libraries. There are some very cool libraries which are integrating these APIs together. For example, Babylon.js is integrating the Camera API, WebXR API, WebVR API, sensors, full screen API. There are like dozens of APIs that this framework is combining together in some useful stuff. So looking for these. Yeah?
Okay, so isn't this stuff like systemd? So let's do it our way. So we will have soon a browser which will need a half terabyte maybe because you need to have APIs inside. So how this is handled like implicitly? If I don't need the API, do I need to like have it all or?
Yeah. The question is if it isn't a little bit overkill to have all the things, and if it won't totally overwhelm your memory. And the thing is, yes, it's like for example, 20 years ago, browsers were like the smart PDF readers which were capable of nothing, maybe the forms and the validation of the forms. And JavaScript was originally the language for the small things and small validations and alerts and something like that. And nowadays, JavaScript is language for creating the full capable applications. And I actually don't know if it's good or bad. It has some drawbacks. It has some positives. For me, it is maybe more positive because you have very portable applications which can be very, very easily ported from one device to another without any installations or without any struggle. And there is a second thing. Each of these APIs which are actually interacting with your device, for example, with the location or with the sensors or microphone or something like that, are needed to be allowed by the user. You must allow the API before the JavaScript can even touch it. There is the thing that JavaScript can do the computations. For example, it can mine the cryptocurrencies in the background, and it was the problem. But nowadays, the browser has mechanisms to detect such a malicious behavior. When you go to the website which is doing something very strange in the JavaScript, the browser can detect it and tells the user, hey, this page is doing some nasty stuff and drains your battery. Do you want to keep this JavaScript running or not? And you can decide as a user. Probably. I don't know if we are out of time or if we have, yeah. So thank you for your attention. And I will be on the networking party, so we can try to do. So thank you.